medical imaging, which is now called Hope Center, and ARC. And ARC is, I went from ARC.
There's someone sitting there.
Sorry.
Okay.
Yeah.
It's just because like we have such a fun.
We are gonna.
You're
How
What are you guys doing? Do we need an extra table?
Just badgering me into trying some new configuration.
was send you a link.
Do you see what happened to Dan? What happened? Is he? I mean,
I
train
mean,
crash? What is it?
I'm willing to call. What's the word I'm looking for here? Sensationalization of whatever's happened.
Yeah.
Like,
What he didn't
I
say.
suspect.
Though, I was in a train crash, like what I would call a train crash. Is in a train I was on, hit a boulder, and then plummeted down a cliff.
That does,
And they refused to let me refer to it as a train crash.
wait, sorry, the train plummeted down the cliff.
Yeah.
Well,
And they refused to let me call it a train crash because I was like trying to claim back the fact that my laptop got broken and I wanted them to pay for it.
oh
They
my
did
God.
pay for it, and they corrected me when I said, hey, I wrote them a letter saying, hey, I was on this train which crashed, and I would like, this is the cost I've incurred kind of thing. And they emailed me back saying, actually, it didn't crash, it derailed. And I was like, I don't give a fuck.
We're gonna train derail and not crash.
They can derail and not crash. That is legit.
Yeah, I think they're saying crash would be a train crashing into another train
Yeah.
or something like that. It's what they specifically mean rather than a train coming off the line.
It's like-
what happened.
it's
It's
like
just
that-
the line happened to be on the edge of a.
It's like that thing in Hot Fuzz, isn't it? It's like we don't call them traffic accidents anymore. It's like, why not?
Road traffic collision.
Traffic collision, because accident implies that nobody's to blame.
What was the phrase that Elon Musk used when one of his rocket crashed? He used a very sophisticated wording just not to say.
Scheduled disassembly.
Yes.
You know, I'm willing to bet somebody else's face gave him that line because he was not intelligent enough to come back. So.
And the Gannon storm loss of 38 satellites called that uncontrolled re-entry.
Morning.
Would you like a hot coffee straw?
Yeah.
Is that what?
It's the.
Yes, there's a kitchen. Where is the?
I'll take you.
Yeah. Okay. I think we'll get started in around 10 minutes for people online. And yes, Stuart, are you okay to go first?
Sure.
You finished your
What am I
slides.
going first with?
Okay, so, oh no, sorry, actually, Shane, you online? He's online.
He'll be here in a
I'll
minute.
ping him, yeah, okay. Maybe Shane go first.
What are we
Just light and talk some morning.
are we just gonna do them sitting down or?
There's a lectern right there.
I know, but it's not on the camera, so it's a.
Would you like to sit down or would you like to stand up?
I don't know.
I would
I think it might be nice
stand
to get people, well, I guess you're sitting kind of in a place, but maybe standing up would be good.
Yeah.
Yeah? So I think we'll
I will
Shane
say
can sit down if you
the
want.
camera is much closer into the tables today, or maybe it's just the.
No, it's because it's gone
cross-
square. It's because yeah.
So
Um,
what are we gonna do with the camera? Stand up.
I'll hold it.
We'll ask-
Get some good angles.
Yeah. So we go, okay. Is Will like that?
Yeah. go on.
I think we'll go, yeah. Jane, yourself, you two? Yeah,
Sure.
okay.
I don't have to.
Yeah, okay. Oh, good morning.
My website traffic stats is me looking at the website traffic stats while people ask me questions.
Sounds good, sounds good.
So we're doing lightning talks first.
Yes,
How many in-person ones do we have?
second,
How many in-person lightning talks?
1, 2, 3. When Danny comes here eventually.
Okay.
Is that okay?
Yeah.
I mean, it's very fluid. There's not really a plan. Yeah.
Yeah, okay.
Yeah. So, again, you said Joy.
Then you can, because you're a painter. Sorry, what?
So I think we're going to have Shane Stewart and maybe yourself.
Sure, yeah.
Is that okay?
Really formal?
Yeah.
Let's go. Boom. Let's go that side.
How long is this cable?
We have, oh,
It's very nice.
It is, yeah, it's very fancy.
and then,
Because it's AI, you know?
Yeah.
AI gets the money.
Yeah, it's funny, as much as I'm really into AI, it's funny that in my foundation's mission statement, I haven't used this word AI a single time. It doesn't show at all, whereas I'm usually all for it, you know?
Yeah.
For some reason, I just didn't.
It's like obviously.
Yeah, it's becoming
It really
natural.
goes without saying.
Yeah.
you also want.
I went up the elevator.
Yeah, I had some inspiration this morning.
No, but this one.
Mission statement.
Oh, this one, yeah, so this one, yeah. But downstairs.
So I'm gonna send it to you. And
Oh, they might do it from
and
there.
I love your feedback, you know. Like, so far, I've only had people at Goddard giving me feedback, but
Yeah.
that's the heavily.
Oh, so we're gonna be watching your back.
A certain mindset.
Well, I was thinking we could then have this over there.
That's fine.
Lightning talks, who do we have first?
So yeah, it's going to be Shane online, then Stuart.
Stuart,
I
okay.
think Stuart has 2 that might be merged into one.
Okay, okay,
We'll
okay.
find out. And then Mohammed, that's
So you said that I want to also talk about the foundation of what the Americans are.
What if they want to use it? Why would they?
Other lightning session.
Yeah.
That's fine.
Yeah.
Okay.
Yeah.
Yeah.
Yeah, but here.
It's very
Yeah.
backlit, it's
Fine.
Good enough, innit?
My power supply at the hotel, it's
yeah,
really close.
I think it was
USB.
Well,
Yeah.
I have one of those.
I disagree with that.
Fine, yes.
I mean, he at one point just copied his code.
Okay, I think I'm officially hangover.
And then also this is.
Should we connect this to you as well?
Yeah. So it's like.
No, should I connect this to you?
An idea called Python. So I would argue with them maybe offline.
Oh, yeah.
We swapped the, he's like, oh, I just saw you wrote that. I saw use the version of Ian's, kind of long.
use it every iteration of it, I think.
For the lightning talks,
The lightning talks.
Lightning talk.
Lightning talks starting very soon.
Yep.
Shane, are you online?
he was online.
Okay, you seem to be on.
I am.
Great. Are you good to go first in like a few minutes?
Yeah, I can be.
Okay, fantastic. Thank you so much. Sorry, just
Like,
did
how
that when
many
I-
minutes?
Okay, okay.
No, just like, how many minutes? 1 minute? 5 minutes? 4.5 minutes?
30 seconds.
What?
Okay.
How much time do you need?
No, that's fine. Just so I know.
Okay. Wait, cool. I'll put it into the.
What's the white?
Where's the timer? Oh, cuckoo.
Don't tell me to make you roll.
We can have a cuckoo timer.
It is an edge room
You
situation.
can also join UCL guest.
If you are at the room,
I used to, I don't remember.
The UCL guest.
okay, then UCL guest will be the easiest.
Let's make names.
Okay, I think most people are here. I guess we'll discuss. All right.
You get your bus back in Junior.
Yeah, double bus. I forget, yeah, I forget the bus. Actually, someone talked about that.
It's ridiculous how far ahead the rest of the UK London is in terms of public transport. Like for better, more integrated with other services you can pay.
Can you guys see that? So
Yeah.
kind of,
Yeah, looks
Okay.
good. Okay,
Alright.
I think we'll get started. Good morning, everyone, again. Several of us, most of us in this room have been here for the last few days. There's some new people online. What we've been really working on for the past 2 days is really hacking, looking at NDCube integration into SunPy map. We've also been talking about a roadmap and plans for the future. Today is really kind of a little bit different. We have a bit more community talks for I guess what people have been using the SunPy ecosystem for, or what they have been developing within the SunPy ecosystem. Again, this meeting is really informal. So, lightning talks, I said 7 minutes. It can go longer with discussion. We'll have 4 before coffee. So that's giving lots of time before things. And we can also leave it open for discussion. So please ask online or in the room of anything that you'd like to talk about, or even if you have an impromptu lightning talk or a fun slide you want to show or discuss, please let us know. Yes, any other things I need to say? No, I think we're good. Shane, whenever you're ready, work away.
okay, thanks, Laura. Yeah, so I don't have too many slides because it is a lightning talk. I might just show the documentation a little bit more because that's what people can see after the talk. But yeah, I want to talk about StixPy first, and then via StixPy 2 other packages which are kind of important. And so what is StixPy? Well, Stix is the X-ray telescope onboard solar orbiter, and StixPy is the goal of StixPy, I guess, is to be the Python analysis package for Stix data. And so essentially there are kind of, I guess, 4 key things which StixPy does, some of which build heavily on things in SunPy, some of which take inspiration from things in SunPy, and some of them just have to be custom, unfortunately. So the first thing that you need to do if you want to analyze anything is you need to search for and find your data. And so for this, I implemented a custom Fido client. So if someone can use Fido, they can use Fido to find and download Stix data. And it's really straightforward. So again, this is just the tutorial from the StixPy documentation. Again, if you've ever used Fido, it should be really obvious how everything works. So again, it's just, if someone's familiar with SunPy and finding data, they can easily find Stix data using the same approach. So let's search and download the first step. Ooh, sorry. The next step is then data containers. So heavily inspired by SunPy map and time series, inside StixPy there's a product container, for want of a better word. And basically, if you give that, a list of files, a URL or whatever for Stix data, you will get back the correct product. And we have kind of 3 products: pixel data, which is really our science data, because Stix uses pixelized X-ray detectors. Quick look data, again, it's quick look, which is sent down quite often, and housekeeping data. Again, where possible, these containers share a similar API and stuff, so you can call the same methods on different containers, and you should get similar things happening essentially. And then where possible, I try to at least allow you to convert things that make sense. So for example, time series, our quick look data and our housekeeping data, you can convert them into SunPy time series objects for easy plotting with other time series. And then for imaging, we use map to contain the imaging data. So STIX is both a spectrometer and imaging. And then it's got kind of common visualization methods on all the plots. So if you have a pixel data object, you can make a time series plot, a spectrogram plot, or a pixel data plot. And again, maybe I can just show, so in this case, I've downloaded some data, I've thrown it into a SunPy time series, and then you can just use the standard SunPy time series plotting functions for something like this. And you can use standard things to concatenate the light curves and to produce a longer light curve. Then you can download some actual science data here. Again, it's all the same kind of things, and I'll put a link to the documentation at the end. But yeah, go through this and you can make something like this. So plot spectrogram, and you get a spectrogram plot, and these are shared across all of the objects. And then finally, in terms of analysis, I guess there's two main things that you want to do with, well, there's many things you want to do with STIX data, but the two big ones that are trying to be solved by StixPy is imaging and also spectroscopy. And so in the bottom right there, I've shown two little images which you won't be able to read, but that's basically images made by STIX, and this is a spectrum fitted by STIX. And this is where the other two images kind of come in, because again, in the spirit of trying to solve a general problem once, instead of solving the same kind of problem very specifically each time, there's two other packages that are important, and that's X-ray vision, which provides general visibility-based imaging algorithms, which is the way that STIX works. And then there's SunKit Specs, which is supposed to provide general spectral modeling and fitting for solar data. Yeah, I think that's all I really wanted to say about StixPy. So X-ray vision, real quick, there's only two slides left because I know we're short on time, but the goal here is to provide well-documented, readable, and performant implementations of existing and future visibility-based imaging algorithms. So that's the way STIX works. Yeah, it's not super important, but basically it's an ill-posed inverse problem to convert the observations that we have with STIX back into images, which is what we want to do our analysis. So X-ray vision, again, we have this idea of data containers to define APIs we can build software on top of. And recently, with the help of Dan and my Italian colleagues, we created a nice general visibility container. So it holds visibilities from many types of instruments, including STIX and RESI and HXI and things like that. And then we use map and ND-cube for the output images. So you get visibility objects in, you run some algorithm on it, and you get maps currently out of it, but hopefully in the near future, map will be ND-cube. So you'll be getting out ND-cube. We've got a bunch of algorithms currently implemented and a bunch of algorithms on the way. And just as a example, again, the docs are up online. I'll throw links into the chat room later on, but similar sort of stuff, import some stuff, get some data, filter our data out because we don't want to use all of it straight away. Create our visibility object. So this is kind of the core interface that once you get your data into this visibility object, you can then create various different images using different algorithms. For example, here, a back projection or the point spread function, a back projection, a clean algorithm, and a MEM algorithm. And that's basically then what you can see here. This is the projection of the telescope, the point spread function. This is a clean image or back projection, a clean, and MEM. And the key thing here is that it doesn't matter where the visibilities come from. These algorithms all work the same, whereas in the past, each telescope would have its own slightly different implementation of these algorithms. And then real quick at the end is SunKit specs. So what we're trying to do with SunKit specs is provide a spectral data container, modeling and fitting for solar spectral data, in particular with an initial focus on X-ray observations, because we often have to forward fit these and take into account the spectrometer response matrix, which is an off-diagonal array. And in the future, well, the far, far distant future, our observations could potentially be like 6-dimensional with, time, space, energy, and polarization, for example. It is something that you could imagine in the not too distant future for X-rays and for radio observations, potentially. So again, components, we have a spectra object, which is based on ND-cube, and I can't type. That's supposed to be similar to photutils, but it's a little bit different. We need responses, we need models, i.e. solar specific models, so a thin target model, a thick target model, thermal model. And then on the fitting side, we need a couple of things. We need a joint fitting, so we need to be able to fit 2 different sets of observations to a single model simultaneously. And we need non-Gaussian errors, and we'd like to support multiple backends. And yeah, so between myself, Laura, and Danny, we coded up the solar models a long time ago, essentially, I think probably 4 or 5 years ago now. And then our colleague Chris went off and, unbeknownst to all of us, basically solved all of our problems and wrote the modeling and fitting kind of side of things, which is great. We had a working version of everything, so you could actually fit data and it all worked nicely. However, the code was very difficult to modify and maintain and try and, I guess, work with. And so we began the Great Refactor, where we wanted to rewrite things using well-defined interfaces and APIs. But it's really hard to write well-designed interfaces and APIs, so it's something that we're really struggling with it. But progress is that we currently, right now, have a basic spectrum object. We have our solar models as AstroPy models, and we have a working version of this based on an AstroPy fork. We had to change some very small things, to be fair, inside AstroPy to get this to work. And again, you can look at loads of lovely examples, but these examples are all using the old code. But here's an example using the new code. And the only thing I'd like to really show here is how we define our models, because this is the really nice part. So here again, we're defining our spectrometer response container / model. And so again, we have these models, we rely on the APIs to build things. And here's the cool thing, we've got the photon model that we want to actually fit. And instead of being a few checkboxes on a GUI in the RESI area, you actually have to say exactly what you want to do. So know that we want to scale all of our models to be at 1 AU. So we have an inverse square flux scaling. We have a thermal emission model, a thick target model with some parameters, and then an albedo correction. That's due to basically X-rays that are reflected off the solar surface. And then we create our compound model by this one line. So what this is basically doing is it's creating our photon model on this bit here. It's then passing that photon model through the albedo correction, because albedo adds extra flux, and then finally through the SRM model. So on the left-hand side, you have photons, and on the output side, you have counts, which we can then fit to the data, and you get a beautiful plot. It's like this. Yeah, so this is a working version of our new refactored code with some sticks data fitting a non-thermal and thick target model to some sticks data. So yeah, I've gone over time, so I'm going to stop now.
Great, thank you so much, Shane. I see you have some thoughts and some issues.
Yeah, there was a couple of like things that I think we could maybe facilitate a little bit better at a SunPy level. So specifically, if you have time series objects, but they're from different places in the heliosphere, i.e. you've got a GOES X-ray light curve and you've got a STIX X-ray light curve. At the moment, if you want to do the light travel time correction, you have to go in and manually do that yourself, right? And the way that people do this is they'll often go in and take out the data, subtract a number from the time arrays, and then put that data back into a time series object. I think that's a really bad practice because you're likely to forget what you've done, and then when you try and compare things, it's going to be bad. So maybe we could add a property on time series, which would be like a time offset or something, where you could set it, and then internally the code would do the changes, and that way it's tracked in the object. Yeah, that's just one thing. The other two, yeah, I mean, AstroPy is really, really difficult and stubborn to work with if you want to go outside of what it, I guess, is designed for. And when we have like n-dimensional data that we want to be fitting, yeah, it can be really difficult to do. And maybe it's something that we might want to think about, having our own modeling and fitting package that's inspired by AstroPy, but maybe isn't as, I don't know, specific. Yeah.
Yeah.
There we go.
That's really good. I definitely agree with Solar Orbiter in particular. We need to think of a way to deal with the time stuff for sure. I guess we talked a little bit about modeling yesterday. Did anybody have any thoughts on this after James talk?
I mean, I definitely don't want to write my own version of it.
Yeah, neither do I, but I mean, essentially, I think that's what we're going to have to do for SunKit specs. Yeah, it's, well, unless AstroPy are open to like heavy modifications of it.
Could we, I mean, this sounds gross, could we wrap around the AstroPy stuff into a way that makes coherent sense for specs? Or is it totally usable?
I mean, yeah, but potentially, like essentially, like to make our current code work, there's not too many changes. But essentially, what we have to do is that we pass n-dimensional data as 1D data. So everything is treated as a 1D model in AstroPy land, but it's actually not a 1D model, which seems like a horrible, hack and really confusing to end users and myself. It's something that I think it will be good to sit down at some point and try and figure out a way forward. I know that we had a conversation with Tom and Stuart a while back, and there was some ideas, and we did make some progress. That's why we actually have a version that does work now, but it's a very limited version, and there's definitely things that we need to add to fulfill the goal of the package.
I mean, we should definitely look at adding them upstream, right? We should definitely try and do that. I don't think, like, AstroPy modeling is a bit of a maintenance nightmare. Like, as it is, it's very complicated and it's very old.
Is it used extensively in the package ecosystem? Because it's not really used in AstroPy itself that I've seen, like within the core AstroPy package.
No, well, no, not really. It's more a thing that is provided rather than a thing that is used.
Yeah.
GWCS makes heavy use of it, as does JWST. They're the big consumers. But I think it's used in multiple places for analysis and stuff as well.
Yeah.
We should definitely have, just start with good issues on AstroPy, trying to figure out, knowing what the limitations are and trying to fix them. I think the AstroPy modeling maintainers will be open to reviewing significant pull requests, even if they're not going to be willing to write them.
Yeah, fair enough. I guess one of the things that we were talking about specifically for SunKit specs is like the life cycle of getting a change into AstroPy and getting it released.
Yeah.
So if we want to release a stable or a version of StixPy, let's say, or not StixPy, SunKit specs within the next year, I don't know if we'll be able to get the changes into AstroPy soon enough to do that. Obviously, we could get them into main, which is okay, but so there's some, like, I don't know, governance or management issues around how we can do this as well. Like, we did talk about maybe trying to like extern AstroPy modeling and keeping it up to date with AstroPy and making our changes just so we can progress and then slowly get our changes merged into AstroPy. But I didn't like this idea because it seems like an awful lot of work. So maybe we should talk about any good options to try and do that sort of stuff either.
I mean, SunPy releases pretty reliably every 6 months, right? So if your horizon's a year, you should be able to manage.
Yeah, I guess. I mean, we had some PRs that didn't get into 7.1 for whatever reason. I don't know why, which is unfortunate, but yeah.
Yeah, you do need to, around feature freeze time with SunPy, you do need to make some noise on a pull request if you want it to make sure it gets in. So they're pretty good, but that is a process that does need to be like actively managed to some extent to make sure that it gets reviewed in time.
Okay, so maybe for the next release, we'll just plan to make some friendly comments on the issues and try, or the pull requests, and make sure that they get merged.
I think the next release is also going to be because SunPy changed their release like schedule. So SunPy 8 is going to be a release where breaking deprecations and stuff can be added. So if you do significant changes to modeling, now is the right time.
Okay.
I'm happy to help as well, and I'm happy to bully Tom into helping. So.
Okay, sounds good. Maybe on our side we can try and firm up some of our specific issues, and maybe we can help guide the discussion. Okay, thanks very much.
Yeah, I think the hardest bit is going to be teaching the SunPy modeling maintainers what you're actually after.
Does anybody else have any questions or comments or thoughts on this? No, I think it's like we talked a little bit about yesterday about accessibility of making an affiliated package, or if you have an instrument package like how do you get that into the SunPy ecosystem? And I think what's been key here is that how the SunPy ecosystem works, so you started from knowing that, right?
Yeah, 100%. Yeah.
Yeah, and I wonder how we can make that better for people who aren't, like, from your experience, have that knowledge, and how do we make that clear to someone who wants to come along and do such a thing on an instrument level? It would just be interesting to get your thoughts on that. It doesn't need to be now, but just food for thought.
Yeah. I'll try and think about it and maybe come back with some comments in the chat room or later on.
Yeah, awesome. Thanks so much. Great. Okay, so coming on now to Stuart. He was going to give.
We're going to do both of them.
Both of them, if you want to.
I don't mind.
Yes, we're going to get a collection of talks from Stuart.
One isn't really a talk.
Okay.
To be fair.
A collection of thoughts from Stuart.
Yeah.
Okay.
I guess I'll go stand up. Gross. Okay. The first one is we're all going to look at this website together. I don't expect this will be massively long. I just thought it would be. We've been running like visitor analytics on all of the SunPy.org pages for a long time, like at least a year or so now. So I thought it would be interesting to just chat through what things are the most visited on our documentation. Here you go. Here's the last year's worth of stats. Lots of people hit the root domain. That's the index of the example gallery, the index of the tutorial, the installation documentation, root of the documentation, more tutorial.
Period to stay like is it just a week?
That's exactly what I was just thinking. Someone take a Fourier transform with that, please.
It has to be a spike at like 5 days, right?
Current week, there you go. Current month. Let's see. No, don't turn it at me. Don't know. Yeah, I don't know what that is. So I think, yes, this is our first example. No, that's from the tutorial. Okay, interesting.
Just acquiring data.
Yeah, specifically the JSOC one is very popular.
Is that the cutout one?
No, it's the tutorial,
Yes, tutorial.
the acquiring data JSOC tutorial.
Which is not the cutout one.
Because the acquiring data itself is higher up.
Yeah, the root of acquiring data is there.
What's the most hit gallery example?
That's what I was just about to look. What's that? Root of the gallery. Goes XRS.
Okay.
Goes. Map index. Goes event list. Cedar web. What? Okay.
We should spend some time.
I think, yeah, it's also, they're like the first few ones on the example gallery too,
Yeah.
right? I think that's also biased.
I like-
On the example
we-
gallery, they're the top. Yeah,
Are you saying we should take the one that's at the bottom and hike it to the top? Experiment.
just present them in a random order every time.
Yeah.
Randomly shuffled every day.
yeah.
Yeah.
Right, so you go.
It's literally the first one. Okay. Good.
Yeah.
Good bias analysis there.
I think we should introduce a gallery of the day. Example of the day.
Yeah,
Example of the day would be fun.
What's the period? Is it just like weeks? Is that like
Assume
weekends?
so.
Yeah.
It has to be, right?
Yeah.
So what's that? 29th of June. What's that? 7th of July. 7th of July. So yeah, it's about a week. Yeah, it's a week.
Oh, is it literally last year?
Yes, this is the previous 12 months.
Okay, cool.
Yeah, it's nobody does SunPy at the weekends. The fools.
What happened to the JSOC example?
The
Request.
JSOC example used to be the cutout example used to be really
Yeah,
high
it's
up,
like
but
they
now it's
put
like
like-
way down here.
I actually have a theory for this. I think it was one person and they finally learned how to get data.
Well,
Is that not the leak though?
Oh, maybe we-
It has to have gone somewhere.
Oh yeah, it's gone. Yeah, you're right. It's gone completely flatline.
we skipped it for a long
No,
time.
no.
And because the JSOC wasn't working.
Yeah. Exactly, yeah.
Completely flatline.
Back again.
Yeah.
Well, JSOC's back again too. So
But
Yeah.
people really were
We
looking at it.
just unskipped it the other day, I think, to be able
But
that's why.
that's interesting though, because it's still there. Even if it's skipped. It's interesting that nobody was clicking on it because it was skipped.
Well, the cutout service also just didn't work for like 5
yeah,
months.
but why would it, like it almost makes sense that it would get more popular when they try and get JSOC data and it doesn't work. And so they check this. Was it not actually there? Did the docs get rebuilt
No, it was
without
just,
it?
it was just skipped. So it should have been there.
It's that one, isn't it?
Yeah.
It's still at the same path. Acquiring data, downloading cutout. Is that that one?
Pretty
Yeah,
sure.
yeah, it's still there. Still the same path.
Yeah, but now, because there's two pieces.
Oh, no, sorry. It is not the same path, because if it was skipped.
Yeah,
skips
it's
in
not the same
file.
file name. That's why.
Oh, yes,
Right,
of course.
find it.
Yes.
Find it. Search skip.
We skipped it when we started, when the JSOC went down, and then we just unskipped it like last week.
Oh, that's a field line figure.
Oh yeah,
There you go.
there you go.
Perfectly.
It's still the best one.
See what's to look
I
at.
was close though actually, because I think Goals was about 1100 as well, and those two together are 1100.
It's magic.
So it's pretty close with Goals.
Reprojecting AI and HMI together.
Do you have any, like, how long back does this go? Can you see it grow over years?
This is currently showing the last 12 months.
Yeah, but can you go like see what it was like in 2018 or anything?
No,
Like,
we've only had this up for
So I was
just over a
maybe
year, I
that-
think.
Okay.
Can you make up the statistics from it?
See, do you see the dates at the top? Can you set that?
Yeah,
Extract.
yeah,
Can you set that
Yeah,
back to like till 23 and see? Oh no, okay, so that's telling you how far back it goes then.
It goes back to April 24.
Yeah.
There you go. That's the
It's kind of surprising that it's, well, I mean, the periodicity, but then it's also flat. Like, it doesn't seem to be
Interesting.
like at all the time. Yeah.
Oh, because people learn and don't look at the end, right?
Yeah. And so, over the weekend, they forget it. They have to
Yeah.
come back.
Yes.
Anyone? I thought this has been a fun discussion.
It's interesting to see, I think, what people are going to the docs for.
Exactly.
Like that, we should maybe be thinking about, like, that informs what other docs we should write.
Some of
So what do you
these,
put on the top?
some of these stats are kind of interesting as well.
So maybe
Maybe this one
Yeah.
and this one.
Stuart?
Yeah.
Is there a way, can you show maybe the region where we start, when NASA started to be impacted by the rifts, the budget cuts and all that? I was curious to see if that impacted the statistics of United States connections to SunPy. Because suddenly, people were scrambling, they stopped working literally on science.
Okay, so
And I was wondering if you just isolate the United States statistics, if you see that effect.
You can actually see Goddard.
yeah, what's the price? 10% of Goddard, apparently.
What's in Maryland?
What could possibly be that?
So specifically the Maryland, because it's Goddard
Wait,
to the
have you got
seventh,
a
and so they suddenly stopped
Every time you
doing
vote,
science.
every week.
Yeah, that's right, yeah.
What date was the
It was
budget?
interesting.
So no, I mean it's
Yeah.
we need to start since the first DRP, the first
It's not-
resignation program.
That's
So
not gonna be impact, I don't think you're gonna see that yet.
in January, February, that started.
Yeah, but
What's your hypothesis? Is it that like people freaked and started going to it to like
No,
see if
no,
it's gonna go, or that it's dropping off because people are hopeless?
Yeah, not hopeless. It's just they stopped working on science, so they would not. I mean, myself, I stopped completely doing any code, so I stopped looking at SunPy documentations, and I'm sure it's the case of many other people that people just couldn't work. And yeah, I'm just curious
Sounds to our client.
because ultimately, these kind of things I need to show these metrics. Anything that is quantifiable, it's always very useful
I would,
for the impact of what's going on in the US.
I would imagine you would.
If you have such
probably-
metrics, that's evidence, and I can use that for, pitching our dear wealthy donors, the foundation.
You pay for this, Stuart.
you'd probably have to download the data and do some actual analysis.
Yeah,
I can't.
I'm
I
here.
can't obviously see a trend.
That's fine. I'll have a look.
I bet over probably the next year, you'll probably see that. And I'd be surprised if you saw it yet, but it's gonna happen. I think you're right.
You're saying like, okay, 25% US, 10% Maryland, or whatever, but I think it's going to be completely swamped in the noise.
Well, I think it can still respond like, the stock market, where there's something very specific that happens, and then we see an uptick of non-activity,
I think
a response.
Yeah, it just
suddenly.
depends. It's like Alistair was saying, it depends on what percentage of the traffic is actually driven.
Yeah, I think you'd have to have all the traffic almost be
Yeah, 670
American
basically.
public
Okay.
researchers
Yeah.
for you to see it.
But it's possible. It's definitely possible. Like, it's clearly had an impact, on US solar physics.
And scroll a bit down to the locations again. The locations. So you got US, India, UK, Germany, and then
It's actually a good thing to.
It's interesting that it's
it's not refreshing.
Chinese researchers, but not living in China.
Sure,
Yeah.
it's not-
Yeah.
it's not-
It's a good project.
it's not
Yeah,
responding.
I think the thing is going to be
Yeah,
here.
it's been a while, by the way.
But yeah, definitely. We need to see how it evolves. There's a lag between as well, I think.
Or is he putting me on the spot?
why do you think?
I'm glad I just put my webcam. Why is it me there?
Do you know what the least hit URL is as well, Stuart? Because obviously the most hit and least hit would be kind of interesting. Like,
What example? do we-
Contributing to citing SunPy.
No one's ever clicked on this page before.
Yeah.
So you said 2% from China, but the 9% of Chinese.
Yeah, I think that's what I think is Chinese researchers that live in or work at institutions not in China.
Yeah, this is like language your browser search.
Yeah.
So
But
So it's not it's not that we translated the.
no.
Yeah.
It's
Although, good GSOC project, the localization of SunPy docs.
Yeah.
well, we have translated into Portuguese once, and the person who translated it all in a Word document. You are like, really?
Why did they do this?
Well, because,
It's another Word document.
well, no. So we looked at that a while ago, went to translate the documentation.
But it'd be interesting to see, like, are the example galleries?
Oh no, that's not correct.
That's the search.
It's probably citing, yeah.
Citation, there you go, citation.html. So
Okay, not too bad.
not
But as of
too bad,
yesterday-
Not good though.
Wait, as of
yeah.
yesterday, it's now on the landing page. You can click the button. So hopefully that will be interesting.
I would
We'll see
say,
what happens next year.
I would say you only need to go to the citation page once. Yeah, like you're like, oh, I
Per
need,
paper.
yeah.
Yeah.
To be fair, you probably put it in your
Library.
tag file and
And then
It's the
forget
one
about it.
tag file to rule.
then,
Yeah.
So is that website open or is only you?
Yeah, it's public. You go to sunpy.goatcounter.com.
Okay.
Or count your goats. Goat counter is, if you have a website, it's very nice in terms of.
I don't think you're looking for a different solution, but I have a self-hosted plausible
Mhm.
that it's paid for by work, but there's no reason to not put any site on it, and it's a single script tag. Is all you need to turn it on. Is you need to go to the site, enter the URL, then go to your site and enter a script tag, and that's done.
I looked at plausible, but I didn't want to have to host it, and their hostage thing was quite.
The free thing. It's not the free thing. It's quite expensive. Their hosted thing. It's like €10, but then even then, if your site goes above 10,000 hits, which ours or something in a month, which ours do, then you have to pay even more. But yeah, I've got self-hosted on. I don't see any problem with it. If you wanted to use it, I don't think you're looking for a solution.
No, this was free and easy. The only reason this was complex to set up was because we integrated it into the theme, so it does all the websites automatically, and I had to write a little bit of extra JavaScript to not confuse it, because it really is only designed for one site, and I've rammed all of the subdomains, all the doc subdomains in it, pretty much into it, so I had to do that. Yeah. Anyway, I'll move on, but if people are interested, you can. I think you can export the data and stuff. So if you want to do any analysis to it,
7 people are using Explorer at one age.
How realistic is it to get a paper on SunPy stats published in an academic journal? Analysis of the periodicity of SunPy stats.
And they're
7.05.
They connect with some of theirs and earthquakes.
Okay. My day job is writing the Python library for Dkist. So I'm just going to demo that. Yes,
How are you funded with that work?
through NSO, contractor to NSO.
NSO? No consequence since the NSF.
Not yet.
They haven't told you anything, or did they warn you of something?
Nothing specific. I mean, I assume, they've said that the whole project might shut down. So
They told you that.
well, they said that at SPD.
They told you that at SPD.
The NSO director stood up and said that if this budget passes,
Chris Keller.
basically you have to shut it down. So use it while you can. So if you want to use it, you can go and read our documentation.
Oh, this is talk number 2 already.
What?
This is talk number 2.
Number 2. We've moved on to talk number 2. Yeah. We provide a package named Dkist, which is like the user tools, which is what I call the user tools, but it provides a Fido client. It provides a NDCube subclass called dataset that I will show you in a second, but it adds a bunch of Dkist specific functionality for accessing the data and dealing with some of the weirdness of the Dkist data. All of the different Dkist instruments are loaded into the same dataset class. For those who are here over the last 2 days, there is no world access specific functionality in my NDCube subclass. You shouldn't subclass NDCube for world access specific stuff. I have it's very specific. Anyway, I'm going to do a quick demo that I threw together this morning. So the first thing you can do is do Fido searches. So I'm just searching for VBI, which is the imager. Most DKISS data has a reasonably short embargo period, so you can filter by whether you want your data embargoed or not. And I'm just searching for all the VBI data for the last 12 months, of which there are 268 data sets. Each DKISS data set contains many lots FITS files. I think most of these VBI ones are in the few hundreds to 1,000 FITS files, but the biggest VISP data sets contain tens to hundreds of thousands of FITS files per data set. There's many things you can filter on. This table is big. You can search basically all of these things have attrs you can query to you can decide. You can ask Fido for searching for any of these things. So here you go. This is a number of frames. There's like 1,000 frames in that data set. 2,000 frames in that data set. These are a few gigabytes to 20 gigabytes. You've got two main identifiers per data set. You've got a product ID, which is a relatively new ID. The product ID won't change if the data is recalibrated, whereas the data set ID will. So if you have a data set, the product ID is like your canonical ID for that set of science frames, and then your data set ID refers to a specific calibration. It's likely that old recalibrated data sets will disappear after some amount of time. But,
Can I think, in theory, like from DKISS side, this is science quality data that you can do?
This is level 1 calibrated science data.
Okay, and level 1 is the highest level of processing data.
Currently.
Okay, yeah.
Yeah, there's work going on for doing some inversions on the VISP data, which will be level 2 products, but they're not ready yet, but should be sometime this year. So these records, these results from Fido search, each are associated with one single metadata file. If we do this and download one of these results with Fido fetch, you get a path to an ASDIF file. ASDIF is a sort of spiritual successor to FITS that's being developed initially for JWST. I think we just about beat them to publishing live data in their own file format. The ASDIF file contains no arrays. Right? There's no images in the ASDIF file. There's no actual data there, but it is a complete record of all of the metadata. So it has a GWCS object. Let me load it and then I'll talk through it. It has a GWCS object. It has a DASC array. It has a table of every single FITS header for all of the FITS files in that data set. The VBI quite often works in a mode where it takes a mosaic, which is what this is. So this is a tiled dataset object, which is a 2D 3x3 array of dataset objects.
A very nice wrapper.
Thank you. It took a non-trivial amount of time. mostly it was Drew who artisanally crafted this wrapper.
It doesn't include the DASC HTML wrapper.
And it's not HTML wrapper, that's why. Yeah, so this has got 171 frames in an array of 9 tiles, 3x3 tiles. This ASDIF file has not been recalibrated since this dataset was given a product ID, rewritten, even not recalibrated. It has a DASC array, which each tile has 19 frames. It has 3 pixel axes / array axes in each tile, space, time. We have 3 world axes, and then that's the correlation matrix. You will notice that the celestial world axes are correlated to the time pixel dimension. The pointing varies with time. And then you can, basically ignore this. This is a workaround for me to be able to demonstrate something without having to download the data in real time, which would spoil this somewhat. So this is going to think about it for a while and then make a plot of the tiles, but there's no data associated with them, so it's going to be 9 blank plots. But each tile, 9 blank plots. Because the fits files are missing, you still have the Dask array, but it just, when you compute it, it just results in an array of nans because there's no files there. But you can still call .crop on your NDQ, or you can still slice it, and you can do whatever you want to do with the NDQ with no data there. And as you do this, as you do those operations to your cube, this is one tile, this is the center tile, the dataset subclass has a thing that bookkeeps which fits files your dataset refers to. So this is the list of the entire 200 fits files. If you do this slice tiles, what you get is you've still got your array of 3x3 tiles, but now each one is only 1 frame long, right? We've dropped the time dimension of every single tile. And if you then do file names, you only get 9, right? You've got 9 file names for that first tile, right? One tile is 1 file, 1 time step. Each time step of each tile is its own file. And then you can download those files using Globus. So I've got Globus Connect running on my laptop, and the DKISS package will orchestrate that transfer. You can, for people who know Globus, you can orchestrate it to somewhere else if you want to, but that's gone and loaded all those 9 files plus 3 extra metadata files, which is why it's 12. And now when you plot the data, including some nice trickery to make the color scale better, you'll actually have pictures. It takes a while. The plotting code is not fast. I blame WC.
Stuart, just to go back to the Fido thing, I presume you have like a REST API in the background that you're hitting and that you've made a wrapper for or something similar to that. Is that how that works?
Yes.
Okay.
This is the dataset search API documentation.
Okay.
So you can.
So your Fido client isn't programming against the Globus guy.
The Fido client doesn't touch Globus at all.
Okay.
It's only files.
Thank God for that.
It's only files.download that interacts with Globus. To actually, the only thing you need Globus for, is to get the actual arrays. Right, you can get all the other data all the metadata streamed through HTTP. You don't have to go to Globus to download the actual file.
Yeah, right.
Yeah.
Okay, but then when you're doing that download where you are using Globus to transfer files,
yeah,
what are you interfacing with?
The Globus API.
That's the.
It uses the Globus Python SDK and talks to the Globus API. Yeah, that's some beautiful code. Don't look at it. Writing that progress bar to get the Globus transfer status and have that progress bar was an experience I would not repeat.
It's amazing. Their tooling is amazing with that.
So this is the 9 tiles, some sort of small sunspot or something in the middle, not very big, what, 20 seconds wide or something. And because each one of these is an NDQ object and has a WCS and whatever, you can use reproject on it. So I'm going to use the find optimal celestial WCS function in reproject to define a WCS for the stitched together output. You pass it a list of WCS objects, so you can iterate over the tiles in your mosaic with .flat in the same way you can with a NumPy array. When you access the WCS thing, I'm going to downsample this so this doesn't take 10 minutes, and there's a bug we haven't fixed yet. And then you call the reproject and coadd function from reproject, which like stitches the mosaic together. You pass it a list of ND cube objects. You pass it the reference WCS we just created. You give it the reproject function you want to use. Well, I'm just going to use interpolate because it's faster. You determine how big your output array is, which is something that find optimal celestial WCS returns. And we turn off round tripping coordinates because nothing's off disk and it's faster if you turn it off. Reproject now has native support for Dask arrays, so it's using Dask to do this, so it speeds up. And you can, like, if you're doing a significantly larger thing, you can handle out of memory cubes, right? If you can reproject a cube which is too big for your RAM. And then I construct a ND cube.
You got no.
And you can reproject this back to, like, into a single array. Yeah, that's it. I'm done.
That's amazing. Like, it's crazy that you can do that in like what 20 inputs, and like how complicated that data is, and how imagine like this didn't. Yeah, that's
Can you do this an idea?
Probably.
Do you know if many people obviously are many people using DKIS data and using the user?
Some people occasionally open issues when I break stuff. So,
Okay.
Have you gotten feedback from people that like thinking in this more? It's not just you're not just opening up a FITS file or like 10 FITS files and like doing an analysis, like whatever, using like the FITS key, sometimes like moving from that sort of mode of operating to this, where it's just like you have to use these abstractions to work with the data.
I don't think that the majority of data sets we've created so far are so big that you have to use these abstractions. Like, I see quite a lot of people, certainly like with the Corona data is relatively new, and like early on, like lots of people were just bypassing all of this and just working with FITS headers because there were issues with the GWCS and stuff. One of the probably the single hardest DKIS thing has been building a GWCS from so many FITS files, like a really complicated GWCS from so many FITS files. It's the code that does that is a twisted web of FITS header parsing. It's really fun. So I mean, I think lots of people do fall back to just for file in FITS files, go, right? Especially when something maybe doesn't work as well as it was intended to. But I think that the feedback I have got has been that people see the value in it and will use it first, or try and use it first.
Are you going to make this notebook available?
Most of this I've stolen from the documentation, so
Okay.
I've just stopped sharing. But like the VBI stitching example is in the documentation, and we've got a what I consider to be reasonably complete, like read it from start to finish tutorial that takes you through working with VBI with data. Yeah.
Yeah. Where would you like to send it? Yeah, that'd be great. Yeah. Okay. Thanks a lot. Yeah.
Every now and then.
Yes.
For the foundation, it's important that you take pictures when you see these kind of maps with the sun.
Yeah.
But also that.
Yeah.
So, but basically, each time I'm showing a new thing.
Yeah.
You can just run it.
Yeah, sounds good. Okay.
Cool, thank you.
Okay, great. Our next lightning talk is going to be from Raphael, who is with us today in the room, which is great. He's going to be speaking about kernel holes racing with segmentation.
What did you do?
Oh, just
share the.
sharing. Yeah,
All right.
okay.
It amazes me how the easiest way to put something on a big screen is to share the screen into a video call. It's just so very, very 2020. It's like just
So
round trip this video feed via a server somewhere is the easiest way.
Yeah.
All right, now
right, sharing, and then to show as well. Screen.
Yes.
Need to be glad. Okay. Screen share. All right. Use that. Okay. So yeah. Hello. So for those of you who don't know me yet, I'm Raphaël Atier. I work at NASA Goddard Space Flight Center in Maryland. I'm not a civil servant, otherwise I wouldn't be here. So I'm a short, easy word is contractor, but we're not a contractor either, long story. My employer is George Mason University. I'm in a co-op network. Just basically I'm like a Wiz Barnes, right? Similar. But my employer is George Mason University. My office is at NASA Goddard. I've been there for about 8 years. My background specialty is solar physics. I've been specializing into tracking plasma flows at the surface of the sun, and then I got pulled into studying the solar wind for applying various techniques for tracking plasma flows from the imagery of stereo to prepare for the PUNCH mission. And so I'm now the science lead of the solar wind flow tracking group. And we will be implementing a set of tracking algorithms that will deliver the first systematic flow maps of the solar window around the sun between 6 solar radii up till about 80 solar radii. However, that's not really why I'm here. I'm here to talk about another project, an artificial intelligence project funded by NASA ROSES. And I will have my tone will be a little bit grave, maybe sentimental, because this artificial intelligence call is the only survivor of the budget cuts of all the heliophysics AI calls. So, because all the other ones were selected, but then, the orange guy decided not to fund them. So that one, I don't know how it survived, but it did. And we got selected. All right, so this is chess, kernel hole extraction with semantic segmentation. Let's talk about that. We'll dive right in. All right. Okay, so hopefully you all know kernel holes. Now it's time to tell me who doesn't know what kernel holes are. Okay, people online scream. Okay, so you may have used kernel hole segmentation in the past. If you go to HelioViewer and you want to see this segmentation of kernel hole, the sort of go-to algorithm that's referenced a lot is POCA. It's not the only one, but that's the one that you see easily in helioviewer.org. And there's an API, and people can download the boundaries and make their own analysis. But it's an algorithm like other. It has its own uncertainties, and a well-known uncertainty with detecting kernel holes is that there is an ambiguity caused by filaments. And so many times kernel holes are selected, but they wrongly select filaments, and so you end up with data sets that are supposed to be kernel holes, but some of them are filaments, and so it can create problems, especially when in the context of, say, space weather forecasting. I'm going to open a parenthesis. I'm going to talk a lot about space weather as well, because working at NASA and at the heliophysics division, our priorities are shifting. The long range now is very, very much space weather. We have to save our proverbial lives. And so if you go to the website of the NASA heliophysics division, especially the Goddard heliophysics website, you will see that it has a big overhaul of the website. It looks completely different, and the long range now is massively towards space weather. So that is, I'm just preparing you for at least the next 4 years, or until science and democracy pulls its shit together. And so just get used to that. And apologies if you're not really into space weather. All right, so I close the parenthesis. SPOCA has been a really reference algorithm to detect kernel holes. So I mentioned one limitation of it is the ambiguity in discriminating between filaments and kernel holes. And the other thing is that SunPy, if you use at least the API, it only gives you boundary data every 4 hours or so. So you can't really have, unless you run SunPy yourself and you have the whole software suite, then you're sort of stuck with these sort of snapshots that are very spaced in time by several hours. Not great either, right? If you want to do something more granular. Okay, so we decided to improve that, to have a tool that you can apply on any image of at least of SDO, so that you can benefit from the higher cadence of SDO, benefit also from the higher resolution of SDO AIA, and provide also a way to disambiguate kernel holes from filaments. The answer to that is to use a combination of neural nets and a more physically meaningful training set. Our sort of secret weapon in there, it's not the neural net itself, it's actually the training data we're gonna sort of use. And we're gonna use the Helium-1 1083 nanometers, angstrom, 1080-830 angstrom Helium-1 line, because it has the ability to create more confidence levels regarding what is a kernel hole and what is a filament. So when you combine Helium-1, which are observations made from the ground, with AIA imagery, you combine those, then you can much more easily make sure that the kernel hole that you have are actually kernel holes and not filaments. So here is an example of how these data are created and how we go from a basic Helium-1 observation down to more certainty, a more certain detection of the kernel. So first there is very basic thresholding of the image in Helium-1. And then some filtering happens, a little bit of morphological processing, and then you end up at the bottom right with a confidence map where you have a statistic, a probability of the kernel hole of being a kernel hole. And so finally, we applied first a UNet. Everybody is familiar with UNets, what they are, at least in, okay. So UNet, it's a convolutional neural net that has two branches. There is what we call a contracting branch. So you have a series of different convolutional operations that decreases the dimensionality of your data and creates feature maps that holds the most salient features that describe your image. And it has this little, what we call skip connection, that capture still the multi-scale information that, if any, in the image, and compresses that into lower dimensional space, and then you re-upscale that into the expanding branch that you see on the right to get a sort of model of your image with more simple representation of those most salient features. So it's been a very, very basic, I mean, not basic, but an industry standard in convolutional neural nets. And it's from 2015. It was originally made for medical imaging. Now it's been used a lot in solar physics and solar imagery, but there's been variants to it to improve it. And a variant of it is what we call the res UNet. So it's a UNet with what we call residual blocks. It's basically blocks of code, but blocks of convolutional components that are able to extract even more useful information that describes the image a little bit better. When I say better, that was not, and I couldn't say that until I tested it myself. And so I developed then my own res UNet model, and there is not one single res UNet model. There are many ways of implementing that. And so I haven't tested all the possibilities, they're infinite. And part of the project will be to actually optimize that in hyperparameter optimization. But here is I'm showing you a basic sort of proof of concept, because when you write a proposal, it's very well known, at least in the US, that you basically need to have done the work already to be funded for it, right? So that's what did. And so here's an example of applying this ResUnet on an AIA map where I didn't have yet the data from Helium-1. So I basically took the same data that SPOCA uses without any input from the Helium-1 imagery, just AIA. So the result of the segmentation of the coronal hole is here in the middle. So the yellow stuff is supposed to be the coronal hole. On the right, you have what we had for the result of SPOCA. So this is our validation set. What's interesting there is that even though we have used exactly the same data, exactly the same type of data with AIA 193 as the training set, when we test that on the validation set, we can see that the ResUnet, even though it was trained with SPOCA as the labels, as the training set, it's able to make a better job at extracting coronal hole. Because, for example, if you see the little, can we see my cross there? Yeah. If you see that little patch here of brighter pixels, they're not, obviously they do not belong to a coronal hole, which is defined as a dim region in this case in 193. SPOCA apparently considered that it was part of the coronal hole, whereas the ResUnet had no trouble removing that out. And that was just a random example. I didn't cherry pick that. And so that was interesting. And then I looked at the actual accuracy metrics, and yeah, it's consistent with it. So we can see that in the validation, the accuracy is a little bit better for the ResUnet. It's the red curve, a little bit above the UNet. And so that's interesting because we didn't change the data, we just changed the architecture, and so we had a slight improvement. Now, what's going to be very interesting in that project is that what's going to happen when we're going to add the Helium-1 data, which adds a lot more physics. So when NASA looked at this proposal and accepted it, selected it, then they contacted us and they said, hey, we're working on a foundational model for solar physics, and so far we're lacking the segmentation component of it. So they want to have this big AI foundational model, and they also selected that project to ask us if we could create a downstream application for the foundational model. So I'm working with people from the private industry and also other people from SWERI and basically public, private funded people. And we're working on that, a foundational model where this software suite, these algorithms, these UNets and ResUnets will be an integral part of the segmentation part. Now, I don't know much about foundational model. I was pulled into this sort of extension of the project very recently, so I probably won't be able to answer much questions about what is the finality of that foundational model. Why are they doing that? I don't know, honestly. But this is basically where we're going. So it's going to be very, very interesting. And thank you. If you have questions, let me know.
So right now, the training data is already for AIA 193, right? For your current model.
Yeah, right now, yeah, the sort of proof of concept was only done with AIA data, not yet with the Helium-1, and the whole project that it hasn't started yet. I just got the money, and we're starting in that. That's when we're gonna use now the Helium-1.
And then how much the data that Helium-1 has comparing to AIA-1?
Very good question. So yeah, this is a bit frustrating because actually when I was writing the proposal, when I submitted it, I thought those observations were still ongoing, but they're not.
Yeah.
Right, you probably know that better. I don't know, but so it was a ground-based observatory who were, they had this instrument that didn't work very long. I think it was Solis or
Solis.
Solis. And they had plans to modernize it until everything went to shit. So excuse my French. I'm in Europe, so I thought I could stop swearing. So yeah, we have then a rather limited data set of Helium-1. So this is why it's going to be used for training purposes to create this new curated data set where we know we only have coronal holes and not filaments. But then if we want to really expand and have more generalization over the solar cycle, then ideally we need to have new helium-1 observations. And yeah, I don't know how it's going to happen, but that's actually a good project for asking for funding to private sector, because it pertains to space weather. Here again, I'm talking about space weather. Yeah. Then we can pitch to the space industry the importance of that kind of work to be funded. And so I'm dreaming about a private funded instrument with helium-1 data. Again, we start, say, to build one from the ground, and then we put it in space. Why not, right?
I think Shane has a question online.
Yeah, great talk. I was just curious about the example that you're showing there, where you're saying that the res unit correctly identifies the bright region in the coronal hole as not a coronal hole. And I guess I was just wondering, do you think that's down to the definition of what a coronal hole is versus what you're actually detecting? So to me, that's just a bright region inside a coronal hole.
Mm-hmm. So yeah, that's a great point. You're raising a more fundamental question about coronal hole in general. What is the definition of coronal hole? We only have a phenomenological definition of them. It is dim region into these images.
Is that not a proxy for the more open magnetic field lines?
Yeah. But when you look at the literature, the first definition of a coronal hole is defined not with the magnetic field, but it is defined with the magnetic field, the magnetograms. That is the theory explaining what coronal holes are coronal holes.
Okay.
But it's defined. The coronal holes have been defined by the phenomenology of the coronal observations.
Yeah, normally it's just if you have normally the common one. I think the Spoker one uses that an indicator showing if it's dark enough, it's coronal hole. If it's not dark enough, then it's something else.
Yeah.
And I think probably when I say it's maybe because Spoker decide to fill in the label. I think it's
I'm inclined to think that the reading of ResNet being strictly better than Spoker just because it picks out that bright spot is not wholly accurate. I just think it's depending on what your desire from your algorithm is, which is always the case with AI, right? You need to be able to build your model to be the thing you want it to be, but it's not always easy to actually build the actual model so that we still have to infer the results, which is actually encouraging.
Yeah, no, 100%, because one of the reasons why I asked that is for Chimera, we detect those bright spots, but then we on purpose fill them in. So again, I think it's a question of how you define things. But yeah, cool stuff though.
I think what we're aiming is more accuracy, like what you just said about there is this sort of arbitrary morphological operation that there is a small hole in there, we're going to fill it out. Okay, why? Why? So that decision, is it why that motivated? Because you want to have a completely connected area, no hole in there. Why? And so that's why that's why I was interested in exploring that those CNNs. It's for the sake of accuracy. And if we want to be consistent with the phenomenology, we want to have something that doesn't distort too much of your prior.
I think it's interesting that given the current phase the sun is in, it gets us much more insight into coronal holes. When I was doing my PhD, the sun was quiet as all balls, and so didn't really get any coronal holes to look at.
Yeah,
just didn't. So it's quite interesting.
Yep.
No, yes, Shane already answered my comment.
I have two questions. So this is really interesting, Raphael. From some part perspective, are you planning to use SunPy for this?
So, thanks you. Yeah, I thought I was forgetting something. Why I'm here? Why am I here to talk about that? Yeah. So because it's convolutional. It's a UNet. So ResUNet. These are just codes and weights, and that can be a part of SunPy. And I came here just to gauge your interest in having this kind of software suite. You would have, instead of having a database, a data archive like Spoka, where that people query to overlay their kernel holes, and you don't have to store because it's so efficient that you don't have to store a data archive or kernel holes. You just store the code and the weights in SunPy wherever, but then you can run the code to immediately get your kernel hole. You don't have to store a whole data archive of it that's going to run into the historical data of AIA. It's just a function now. Oh, give me the kernel hole here.
So you pass it a SunPy map and you say, we need
Yep.
to work on this. Okay.
Yep.
And I guess, are you using SunPy to get your data from the JSON?
Yeah.
Load it into map. Take the,
Yeah.
are you
can,
doing any prepping?
you can build then your a more sophisticated pipeline at reduced cost. At reduced operational cost, because then if if the API breaks, the connection to the HEC sort of breaks. I mean, you don't need the HEC anymore because you can generate your own segmentation. So I came here just to present the aspect of implementation operational capacity that SunPy can offer when it couples when that algorithm is coupled with the power of SunPy. Just natural fit.
I think you still need a database though, because while the algorithm may be extremely fast to run, you still have to download the data to run it on. So if you want to get kernel hole properties every hour for the entirety of, let's say, the AIA mission, you'd still need to download all of the, whatever that is, 193 images at that cadence.
That's what Laura just said. You use your SunPy to get your data, so that's already there. This is the capacity.
No, Shane's point is that it was a lot less data to download the mask.
Yeah.
Like if you want to download the Corona mask for every hour, that's a smaller data set than downloading all the images and running it yourself.
You would still need to generate and put the mask somewhere, and so that would
I know that's the point, right? I think that was the point he's making, is that it would be good if the masks were generated and put somewhere.
Oh, right. But I mean, don't you have in SunPy a tool to get your data? You already developed that tool to get your data.
For sure, but it's a matter of okay, then say you have this model that does this, and you're like, okay, I want the masks of all the corona holes over the past solar cycle. Then I need to download all of the data to do that, and then you could produce that as a data product, right? Yeah. I mean, it's muchness, right? It's just a
no. It's super useful both ways, but I just think it doesn't negate the idea of having a database like HEC where you have pre-processed stuff, so people don't have to download all of the source data, because I mean that would be hundreds of gigabytes, not terabytes, I think.
Okay, I'm going to take a few steps back just to remind again what I said at the beginning, that if we're talking about creating a new database and these kind of things, so this is not really where the direction that NASA is going to, or NSF, because again, we're being gutted financially, so you want to have cheap tools, right? Get used to that for the next 4 years. So now this is where SunPy can really make a big difference to show its sort of untapped value. It is already being seen as a great value, but that's an opportunity for SunPy to provide an augmented experience at which for the user is going to be a reduced cost. Because SunPy is not going to store the mass, and all of that's going to be run locally in a computer. So this is, I think, the power of these kinds of algorithms. Because usually when you do a study, you don't need to, people are not going to download the entire data archive of AIA. On average, the regular user is going to look at kernel hole and snapshots. And so they just download a couple of images, and then they get their kernel holes. You have no idea how many times I got requests to provide kernel hole boundaries because the people were trying to get that in the HEC. Well, they didn't have it at the date they wanted, or the segmentation was obviously terrible, and they were frustrated with it.
Is Spoka open, like the code?
Yeah, it is, but it's completely because I used to work at ROB with the people who made it, and when I asked them the code, and they say, oh yeah, we give you the code, but we won't help you, we won't support that, we don't provide support, right? So you're on your own. Which is not very, what I would call open science, but anyway. And the documentation is at what it is, and they will not help you on that.
It's not like an open source project, it's just publicly available.
Yeah.
Open source, not open development.
Yes.
Yeah.
Yes. Yeah. Whereas with us, with them, we'll be as open as you want it. We'll be as open as you want us to be, because it's actually in the mandate of NASA to do that for you. For now, yes. Good point.
Great. Anybody else? Okay. I guess we can break for coffee now, and we can continue to discuss this. Thank you so much for So we'll have a 30-minute coffee break. We'll start back at 12. We have then one, is Joy going to talk?
At noon, yeah.
At noon, okay. So we'll have Joy and then
The
Mohammed.
first speaker during
Yes.
the PhD was rural properties, study analysis.
You're one of the
And
first
we
people I
spent
met when I
the
started
time
doing
doing
this.
image processing.
The Canary Islands back in, I think, like 2014.
Basically, the,
What data, what?
I was doing my first like internship, and you came to teach people about SunPy.
trying to
You were my first.
algorithm and automatic.
In the.
Basically,
in the.
like, I think trying to do that
At the
is so much easier
Yeah,
now. At the time, you just couldn't definitely didn't work.
If-
Like, and even if the journalism said there's something,
No, yeah,
I'm not sure
because
we
there was
have
something
like
else.
the
I think
big
there was
beam
this,
that's like
European space
bits.
You were something there.
This is very interesting.
Pass by.
Oh, yeah.
I went on to like
It's
data
many
science
years
in industry through
And you remember me?
Yeah, of course I remember.
No, I remember we were talking, and like they say, like the first thing I said to them is like, this is my first talk in Spanish about SunPy. I don't think that no one has ever talked about SunPy in Spain. So we have to decide what do we call it. Do we call it SunPy or SunPy? Yeah, SunPy one.
I took a lot on my own.
And then I remember you sitting, like people were sitting at their desk and you were crouching like this, being like, and then you jumped this and then you put it here.
Yeah, that was with Manolo and.
Yeah.
Oh, so you were doing?
Do we each give you the big sticker?
No, I was doing like I don't know the names in English, but I was doing my
You agree?
my licence, I don't know what it's called. Just like a bachelor's, yes.
Bachelor's.
I was doing my bachelor's grade, and I was working with Chloe and.
Oh, you were, yeah. Because I think I was staying in her place that week, I think, because.
Yeah, I think we went dancing. I don't remember.
And I was there too.
Yeah, you were there.
Yes.
This was like a
Yeah, we were talking about like, did we go dancing? I don't remember.
Then you know you went
Yeah. But I remember that one.
in. Good to see you.
Hey, you didn't get my hug.
Congratulations.
Oh, you didn't get my hug. All right, how are you doing?
I'm
Where do you work
good.
now?
MSSL, so South Pier.
Okay. Yeah, you left at the right time.
I know I
Avoided
did.
the whole shit that's going down.
I know
Yeah, so-
I did.
You have me in this building, so I'm gonna show you. There's a coffee and toilets and.
Awesome.
At the grass.
Where are we? Are we just having coffee?
Yeah, I think we're just breaking like 30 minutes. Yeah.
hiding.
Sleep. I need to delete this. This horrible file that I added. Bouncing between 15 different things is not really useful. Right. Otherwise, extra file.
What is the, I forgot the word for E4 state conversion. Split. Coercion.
Oh, coercion. Yeah. Oh, you're just fixing that? Yeah.
I've
That's,
already fixed it.
yeah, that's already, yeah, that's, I'm already dealing with. Thank you. The second file is the issue.
Yeah.
First, I need to get clone.
Everyone published the branch.
Can if you want, if you merge it, doesn't matter. CI stagnate quite a bit. To fix those steps. Well, what did you change the?
Array.
Yeah,
Let's
yeah,
just say,
yeah,
is this the one we found the other day? Is this in a different package? Remember you said, I don't understand how this is though, because it was NumPy 2. Was that this one? Is it the same one, or is it a different one?
I don't know. Honestly,
Because it is the same.
oh
issue for the
yeah,
other
there's
day.
like a NumPy dot
Because it,
array close or something.
Yeah.
Isn't it testing? It's like,
yeah, oh, that was it's a different one.
Yeah.
Yeah, because that was a start close, which means it subtracts a tolerance, and then it can't coerce. It can't coerce the string into with a subtraction, but it can with like into a int.
Did I fix? I forget to fix that file. Cube. Check out. Just show this. There's my tab, Python time distance. Yeah, no, I haven't told you. Some random guy from allegedly Cardiff, or this Cardiff is a surname, has just been emailing me like it's been like emailing me like
Yeah.
no, it's all Python.
Oh, is it? I saw the
really,
.sav and I was like,
yeah, it's like it's like taking fix files, cropping them, dumping them as SAV files, and then reading them back. And I did not want to get involved in that part because I was like, I don't care. But it's basically like, oh, I need my figures not to have units, and I need them to be square. One's a bug in AstroPy, which Tom has asked me to review. The other one is like, oh, you have rectangular data, you can't represent that as a square. Just physically impossible. No, it has to be a square. Like, you're taking a slit across 400 images. Your like raw data array is like this, right? Like, it is sausage-like. Like, how do you want this as a square? Like, it doesn't
shrink one of the like. You can change one of the thingies, couldn't you? Like the axis scales. I remember I used to back in the Matplotlib days. Used to always be setting axis equal. Because it would like sometimes just be slightly off, and it was annoying. Because otherwise it'd rescale your stuff. Small and a lot of people register. So sorry.
Hello.
You've booked this room for like the next hour as well, 12 to 1?
Yeah, it's the whole.
The whole day?
My understanding is the whole day, yeah.
Okay. Thanks.
Excuse me. Is it where the presentation is happening? For the Elise seminar?
I believe, no, I don't think so.
Hello. Oh, it's somewhere else. I'm looking for like a seminar.
Which seminar?
Elise. Yes. I think it's in this building. What is it talking about?
brilliant. They're organizing an event happening here.
Yeah.
That they haven't booked. And they invited everyone to come here today.
Okay.
But we're not doing because it's like, I mean, and they told me like now, like only 5 minutes before they are supposed to start.
So are we getting kicked out?
No, we book it.
Okay.
I'm not gonna be kicked out.
Vista. Vista for Linux.
Come in this shade of the ginormous plasma belly looking down on us.
Right, I'm gonna go. I've got to get home. Heavy's gonna resent me for being away for 3 days, and then I got to flea treat him, so that's gonna go so well.
There's no seminar here. That's the only thing. I don't know, but I think it's there doing it in the kitchen. The AI seminar.
Yeah.
It's probably in the kitchen rooms.
Definitely said function.
They didn't book it.
I think we have most people back. Hey, Joy. Yes, please do. If you can hear us, okay? Hello. Yes, we can hear you. Hello. Okay, so welcome back, everyone. We're going to have two lightning talks this side of, two lightning talks and then a discussion on engagement and community before lunch. So we're going to have Joy first and then Mohammed after. So yes, Joy, whenever you're ready, please work away.
Okay, thank you.
I'm in the call, but I just by myself.
Full screen?
Yes, it looks like a full screen.
Okay. Sorry about that. Hi, everyone. My name is Joy Velasquez. I'm from the Harvard-Smithsonian Center for Astrophysics. I'll be presenting XRTPy on behalf of the XRTPy team. So XRTPy is a fully open source Python package designed to modernize how we analyze data from Hinode XRT. Okay. So before I introduce the software, just want to give a quick outlook at Hinode the XRT instruments. XRT observes the solar corona in the soft X-rays using a series of filters to capture the emission at different temperatures. Observes between 1 to 10 million Kelvin. It's been operating since 2006, imaging everything from coronal loops to jets to flares and CMEs. I want to show you a quick video that was used using a Jupyter tutorial available in the XRTPy site. XRT is capturing a CME here using the AO poly filter, and these are some of the capabilities that you can do using XRTPy. So our scientists, just want to tell you a little bit about our scientific motivation. The original analysis tools for Hinode XRT were written in IDL, which has increasingly been outdated and less accessible for new users. So XRTPy brings these capabilities into Python, making it easier to integrate with tools like SunPy, AstroPy, and the broader heliphysics ecosystem. So our goal is just to provide a similar but more modern framework that scientists can build on, to teach, to build on, and to extend. I'd like to just tell you a little bit about our core capabilities. I'm going to begin with our channels module, and channels is where you can find all information about the instrument and its metadata. So here I'm just giving you one example on how you can use channels. You simply give it one of XRT's many filters. And what I'm showing you here is the specific filter we chose, which is titanium poly. It tells you about the filter, its different coatings, its thicknesses, and density along with units. This is exactly how it would be used if it were in IDL. We also do effective area modeling, which computes time-dependent effective areas using contamination profiles. So what you're looking at here is the wavelength versus the effective area of observations in the orange from 2006 and in the blue 2023. And what I'm trying to show here is that you can do analysis as you would in IDEA with Python. We also do temperature response curves. What you're looking on your screen is fairly close to the launch state, which is the temperature response curves for all of XRT's filters using the different Chianti abundances available, which is coronal, hybrid, and photospheric, showcasing the different temperatures XRT is able to observe with its corresponding channels. Furthermore, we have image correction. This correction improves the clarity and contrast, making data more suitable for accurate solar analysis and diagnostics. What you're looking at on your screen on the left is an image. And after applying image sharpening on the right, just makes a lot of corrections to the visible straight light. You might not be able to tell on the screen, but you'll definitely showcasing your data. And last but not least, we do the filter ratio method diagnostics. So it computes the temperature and image measure maps from data from image pairs using the filter ratio method. So what we do here is we take two XRT maps fairly close in time, and we apply the filter ratio method to show the temperature and emission differences here. So all of these modules are available in our documentation site, and we also have corresponding notebooks. I just want to highlight here that XRTPy is fully documented at xrtpy.readthedocs.io. It includes a detailed API reference, tutorials, Jupyter notebooks, and a contributor guide. We align with the structure and interface with SunPy. We align with the structure and interface with SunPy design principles, and we're actively working to make XRTPy interoperable with other affiliated packages. So we invite you to try it, give us feedback, or contribute, as this work is community driven. With that, I would like to just say thank you. And here's a QR code if you'd like to visit our documentation sites.
Great, thank you so much, Joy. Does anybody have any questions or comments? I guess is there, is there much, in terms of next steps with XRTPy, is there much left to be done, or kind of something that you need support with, or anything from that side?
I'm glad you asked. I had another slide, but I was deciding holding back. So we have two things we're developing in the works. We're looking to create a DEM solver using the Chianti spectra, or allowing users to insert their own spectra. And we're creating this interactive tool where users can simply give a date, and this interactive tool will tell you what was observed by XRT. That's currently what we're working on at the moment, or our next steps for us.
Great. And are you planning to have the DEM solver within XRTPy?
Yes.
Okay.
Oh, sorry.
Yeah.
Yeah, we'll start working on a pull request soon, so you can follow on you can follow everything on GitHub and contribute if you like. Thank you.
Only like a quick question.
Yeah, you're right.
But if for example, if I think like the concept DM can be used no matter what. Is it like XRT or it's gonna be AIA?
Yeah.
It's gonna be like probably it's the same concept, right? Would it be better if we get like actual DEM built into SunPy directly, so it does not really depending on I don't know what it.
Yeah. Did you hear that, Joy?
Is the question is, will you be able to use this DEM solver with other instruments like AIA? Yeah, that is something we have in mind. You are able to do that in IDL, so the idea is to replicate that. So to answer your question, yes, we're definitely looking to make this work with AIA as well.
Yeah.
Laura's linked a package that is not really being worked on, but will sometimes.
Yeah.
Updates the pipelines.
I guess my quick 30-second spiel is this is, as Alistair said, it's like this package that I idea that I just came up with like probably 6 or 7 years ago. That is basically exactly what you were just saying. The idea is that you have like a framework for like how you do DEMs, and then you implement different methods for doing DEM. So it could be XRT, DEM, iterative 2, or whatever the thing is called in IDL. It could be the regularized Hannon Contar method. It could be the MCMC method, whatever. And then you feed your data into it, and your response, your response functions, and then you, whatever algorithm you implement or choose, and then you get out a DEM.
I'd want to say as well, I think it's quite important, but you might disagree, is that since you're at the early stage of this, I would think it'd be a very good idea to put this data agnostic in a separate package that then XRTPy has a dependency on if you want to then use it to do XRT analysis. Because there's already existing Python DEM solvers. There's my one, DMRIC-Py. There's David's one as well, DEM MCMC. And it would be very, very good if you're writing another one that presumably based on XRT iterative. If at least some point in the future it's possible for us to marry these all up in SunKit DEM.
Yeah.
And because currently there is a wrapper for DMRIC-Py that Will wrote, so you can run that one from SunKit DEM. And I think also for DEM MCMC even easier, like it's not as dirty a wrapper. And so you can run all these things in a unified framework with the idea being that you have an ND cube or ND collection or whatever of your images, and then you've got your temperature response function, something that tells you where you get your data numbers from as a function of input temperatures. And you just run the DEM method, whichever one you want, or all of them, on that cube as a method. And it would be much better if SunKit DEM could import your DEM package, like XRT DEM or something like that, and run it. And likewise, XRTPy could do the same.
Yeah, I think that is the way to go for sure. I also do not blame people for not doing that, because there's no, like, SunKit DEM is just a shell of what it could be, and it has been for 6 years, and it's just not had someone who has enough time to really dedicate to like actually building a method beyond just like the one-off stuff that I've done. So I think, yeah, maybe this is a good way to do that. And it also, the idea, like when we started this too, was that it would be like, actually I think it does this now, that it implements sort of a factory approach in the same way that like map does. So you, for example, like XRTPy could own an iterative, like basically a Python version of like the XRT iterative DEM algorithm. And then all it has to do is register that algorithm with SunKit DEM, and then everything is the same. And you can still own the algorithm. You don't even have to have it in SunKit DEM, but then the interface is the same, in the same way that, instruments can own their own map sources or FIDO clients or whatever. It's the exact same.
Yeah, that'd be the dream. Would be just import a method and it automatically becomes available as a solver.
Yeah, and then the interface is all the same.
Yeah, that would. But just something to keep in mind that other people would probably like to use this, and if you like hardwire it in, which is the easiest way to do it, as Will said, we understand why there would be reluctance to do this because it is the easiest thing to do. But if you don't do it, then potentially down the line, this dream of SunKit DEM could become true.
Yeah.
Yeah. That should be your tagline, the dream.
I mean, it would be great because I feel like it's something consistently people really want, and it's just not had like enough time dedicated to working on it. Because it's one of those problems that is sort of deceptively difficult. You think, this is so straightforward. How hard could it be? And then there's just a ton of corner cases, and just doing DEMs at all is a huge pain in the ass.
I think it's also this is probably going beyond the scope here, but there's an issue with the fact that DEMs are very magical in the sense that they're not just something you can expect someone to run on random data and get any kind of a logical result without fine tuning. And that's an issue. You're kind of supplying it. The more accessible you make your stuff, then the bigger, easier it is to make mistakes.
I also think that mystery, I agree that mystery is a bit artificial because of the way the software historically has been built though. Like if you actually boil down like mathematically, like what a lot of these TM solvers are doing, it's like, oh, this is not doing really anything.
Yeah.
You know, it's just like there's like it's just a slightly different approach to solving this like poorly constraining matrix equation. That's all it is.
I looked at time as well. Shane asked a question in the chat. I don't know if you want to answer that quickly. Like he linked.
Yeah, it was just a selfish question that someone used to make us full disk XRT images from, I think, Montana, and they've stopped doing it for some reason. And we'd like to add them back to the new Solar Monitor, but new Solar Monitor is like purely Python. So I was just wondering if you can make those sort of full disk XRT images with XRT-Py.
I guess I'm not familiar with what you mean with the full disk. Are you just asking for like synoptic full disk images?
Essentially, I think so, yes.
NRT
Yes.
as well, like as in today's or yesterday's or whatever.
Yeah, that's actually a good point, Alistair, that they're close to near real time.
Yeah, there's definitely a delay, but we do offer updated images. I think maybe you will be about a week behind.
Ah, okay.
Just because we take time to get the data and then process it and then make it available.
Are these the composited, like shorter long exposure ones? Or is this something different?
Honestly, don't know. They were
Yeah.
they were put in a folder that old Solar Monitor just grabbed them from by knowing the URL. And Montana, they're just like effectively just hot linking to an expected location. We've got no idea what the analysis was.
Yeah.
And who is it making these in?
It was someone from Montana. Like the images look like this. They're basically near real-time full disk images. So we used to get them, you know, I don't know, on the order of hours, you know, behind current time. And then obviously we'd stick them up on Solar Monitor. But the collaborators stopped making them for some reason. And also it was just annoying because we were getting these files and we didn't know what was happening in them or how to process them. So it would be much nicer to do it ourselves using XRT-Py or something.
I just have a quick question. Do you have at least a time reference of when you experienced this?
Experienced like these files or when did it stop?
Yes, when it stopped.
Yeah, I can find out. For
It
sure.
will be back, by the way.
Yeah,
But it's still not something we can use going forward.
But maybe it's something like the Hinode meeting is next week.
Yeah.
We can just find the right person. Yeah, okay.
Yeah, this,
Okay,
thank you, everyone.
thank you so much, Joyce.
I have
great.
a
Yeah.
quick question.
Yeah.
Is SunPy TM on the roadmap?
No, but it should be.
It should be.
It's like
should
a
be.
perfect roadmap.
Yeah.
I agree.
Okay, actually, that's something we could definitely point to in a funding thing and be like, look at this
Yeah.
shell of a thing. You seem to think that.
Yeah. And something that would have a really good impact if someone spent
Yeah.
a bit of
Yeah.
inserted effort on it.
That's a very good one.
You're adding it now.
Mm-hmm.
I'm adding it now.
Stuart is adding it.
Okay, amazing. Okay, thank you so much, Joy. In the interest of time, Mohammed, please work away whenever you're ready.
Hi everyone. Can you hear me?
Yeah, very loud, clear.
Okay, I'm gonna share my screen. Just a second. Okay, do you see my screen now?
Yeah, looks good.
Okay, so hi everyone. Thanks for having me. My name is Mohammed Nilal. I am a research fellow at DICE in Ireland. So I'm gonna present like a quick overview about our recent published paper on a plasma helical flow in the solar corona that was associated with the May event last year. And this is the link for the paper and a link for the research nugget. So first, it started with like we were working on the radio emissions from that event, of the May event, and during inspection of these movies for the eruption, I noticed something interesting. Like I said to myself, like, wait a minute, what is this structure here? Because I haven't seen something like this before. So at first, it looks like a solar tornado. Like I have read.
Oh,
Still audio.
yeah. So you just disconnect.
I think it's Mohammed. As far as mine is.
It's someone else to say something.
Somebody say something.
If you can hear us,
Oh, no,
we cannot hear you.
Jesse's still working.
Yeah.
It's just what happens.
Maybe he can say
Yeah, he's frozen for me as well.
yeah.
Okay.
So it's not just like a local versus a remote.
Can you message him, Laura?
Yeah, I got him.
Oh, from the field.
Not dead.
Not dead.
I know, hopefully he doesn't think there was a.
Yeah, he's just chatting away.
See, here you go. It's a really cool observation. I hope it works.
Yeah, it's really cool.
Yeah.
Alistair, do you think it'd be worth just folding in downward pi into something?
Possibly.
The whole.
But possibly.
Absolutely doing all this cool shit.
I'm partly slightly irritated that already it's been eventually bought, but just just this is more shit. It's more I wrote off the entire. Then I don't mind. I would happily move my repo.
Like if you PR'd it.
Yes,
then
exactly.
Yeah.
I'd happily do that, but Ian's made some changes to his copy. It's so stupid.
Well,
I think I spoke to him once and I said, I don't want it there. And he's like, well, and I was like, I'd rather it was either on my repo and I can give you access to it, or it was on the Glasgow University one, like something like Glasgow Astronomy or something like that.
Yeah.
Where you, rather than in an ideal repo as like a subfolder, which is non-installable or anything like that. There's no wheels.
I wonder if
But one of the issues with folding in memory pi into some VM, it means it's not installable by itself.
Yeah.
Unless you deliberately split a package,
Oh, it's gone.
which is a bit messy. I would happily donate significant portion of time to memory pi. It'd be better to have a proper CI and stuff like that. If that is what it takes to get it added as a dependency in my copy, yeah. But if you'd rather went in to Sunket DM, then that could be done as well. It just means you can't then install it separately if you don't want to use Sunket DM.
Yeah, and maybe it's worth giving people the option, like if you just want to use Ray, like not bother with all the kind of fapping.
Yeah, exactly. Because I think it's the benefit, not necessarily. I think there's a benefit to have it callable as well as callable as.
I don't even know you have to do that.
Actually,
Yeah, that was my question.
So like, I think it makes sense to maintain it. And unfortunately, we'd have to like,
How long have you been there then?
the API interface so that we don't have to keep fixing Sunket DEM. I suspect that will change very little.
Like
It's just added a couple of bars.
Your topic is.
but I mean, maybe if we just, if we just say, okay, your version is this
Okay.
one, version is this, then we can convince Ian to just like, if he wants to make changes.
I just don't understand how you be creating a slowly by doing wants to make changes.
Right.
But I mean, I think, he's obviously not totally, against this method of working, so maybe if we can say, okay, essentially Ian is sort of a canonical
DM.
and this is the method, you want to use the regular one, like maybe we can put like the repo.
What's happening is you've
So
been
you're
able to
taking
use it
like hedge my data?
and you've just done what they said, which is here is the repo.
Yeah, so
I think.
We might want to move.
Yeah.
Yeah.
Okay, I think guys, we might move on because Mohammed has not come back online, and I'll just say you can go
I
next.
was
Can one of you expand on the bullet point in the roadmap draft? I just wrote something.
Yeah.
One by.
Yeah.
And then I got to GitHub with it. I found the name of it.
This is the issue is that.
Okay, guys, sorry for interrupting. Okay, we'll definitely follow this conversation later on, but just in a matter of time and making sure we finish by lunch, I might just move on and talk a little bit about engagement, and then when Mohammed comes back online, we'll talk about it. Is that okay?
Yes.
Sorry for putting in there. Okay, if somebody comes back online when I'm sharing, will somebody say, Mohammed, we moved on and we will come back. Okay. So I guess this talk is kind of building on some of the discussions we had yesterday, and kind of as part of the State of the Union idea of the talks for maybe I'll stand up here actually. So these slides were made this morning. There's some ramblings from myself, but we'll just trying to kind of cohesively put together about, you know, why do we need engagement and what are our community plans going forward? So I guess, you know, why does it matter to build a community, right? You know, we build really good software. We have this, you know, a whole project now, and SunPy, compared to even a few years ago, it really has grown out and taken over, right? If you go to any conference now, you look at any poster, any presentation, people are using SunPy. It goes beyond the user. We have archives now that depend on it. You have instrument teams that depend on it. Things of the future. It's written in like data management plans and things like this. So really the foundational tool for doing solar, and I'm going to extend this to heliophysics research, right? Heliophysicists, when I say heliophysics, I mean outside of remote sensing, looking at the sun, people looking at solar wind and beyond. Some colleagues in DIAS were even looking at the Aurora on Jupiter and using SunPy, which was kind of cool. Not biased by the fact that we were there and showing them stuff, but you know, they could use it, right? And it's kind of a way in to do this. Again, code enough does not make a project sustainable, right? You can write some code, but a huge amount of it is maintaining it and building a community of what's needed next. And I think people are the main part, right? People make SunPy community, including most of us in this room. And I think if we're thinking about engagement, it's really about sustainability, right? So making sure even if we stopped SunPy now and just continued, sustaining it is really important for the whole solar physics science community. And then also we need engagement for growth. If we want to make it bigger, if we want someday to have a magical SunKit DM, we need to get more people involved and to kind of grow and think about funding. And why this is kind of a challenge, right? Where it's, you know, most of this week it's been still the usual suspects maintaining things and talking about things. And how do we make that grow? How do we get new people involved? It's nice to have some new people in the room today and online. And what I mean by this is like not just using SunPy, but like being able to look at pull requests, being able to kind of understand the code base and being able to contribute, you know, whatever that may look like. We want to grow the community and the needs of the community, right? So the new mission coming online or an old mission that doesn't have software available to making use of that data, we want to make sure, you know, that SunPy is able to support that as a project. We also need people to identify issues and bugs, right? We know every time we look at the code, we find a bug. Why has nobody told us? And then again, yeah, identify community needs. I mean, you could write this list endlessly about why we need to engage with the community. And when we talk about the community, who are we talking about, right? There's obviously the users, so solar people, whether that be, you know, researchers doing their science. That includes like students and early career researchers. You know, now space weather operations is quite different to like our typical solar physics community, right? But they're still using very similar data and they're using SunPy, right? So they're also kind of a user, but kind of different to what we're used to, the people we're used to talking to at conferences, right? More from an operational point of view. The community also includes like instrument teams and mission scientists. So like even in pipelines, people are using SunPy. Data providers. So for example, things like, you know, the BSO, which is kind of a more generic one. And then say that the ESA Heliophysics archive is using SunPy, or it allows, you know, they know that their users are going to use SunPy on the other end. And then also developers from other communities, right? So AstroPy is also part of the community and whoever wants to be. So I guess that's kind of what we want to, these are the people we're talking about, right? How are we currently, you know, engaging with the community? We have lots of ways to contact us, right? We have the Matrix chat, which is pretty popular. We have a discourse, kind of like an open platform. We have community calls. We have some presence at conferences, right? And we've been pretty good in the past with like things like SVD, doing tutorials, doing some office hours. We had some discussion about that yesterday. Last year in particular, really good presence at lots of summer schools around Europe and the US for doing introduction to SunPy. That was kind of cool earlier in Natalia when you said that the first time you met David was at the summer school in 2014, right? So it's engaging with the community there. And I think one of the key things that seems to be working the best is really in-person contact. If you have a SunPy person at an institute, that institute is more engaged with the community, right? Because they know how to start these ways of contract, of using the matrix, going on GitHub, raising an issue, talking to people. And I think we need to figure out a better way to do that, right? These are kind of working, but we're having a really hard time, I think, in engaging people even just to contact us, right? And why is that? I think some of the challenges is, no worry, Mohammed, we're just going to move on, but we'll come back to you after this. Hopefully it'll be okay. So I guess what's the issue? We know that people are using SunPy, but why are they not connecting to us? Why are they going, oh, this is a bug, I'll just fix it myself and not tell anyone. And then 2 years later they say, oh, I just changed all my SunPy code locally here. That's not what we want, right? It's supposed to be a community-led effort. And why do we not have new contributors specifically over the past few years? And that doesn't necessarily mean be like contributing a piece of code, but are like actively talking on issues or things like this. Instrument teams do not talk to us enough, it seems. It seems like instrument teams go away, use SunPy underneath, build a whole package, and then go, now how do we shove it in? And that's really hard to do, right? And so how do we get in from the start? And I think a big issue, is this bus factor with our code base, right? I think if Albert disappeared, we would be in really big trouble with our coordinate stack. And if you looked at the commit, without Nabil kind of really running things a lot of the time with maintaining everything, we would have an issue, of course, with stewarding well as well. So how do we kind of build this better to be more sustainable as a project? And I think some of these are my own thoughts and some of the discussion yesterday. I think, and I would say this a lot to people, I would say, oh, you should get involved in SunPy, right? And then that's great, but what does that mean, right? I think people don't have a clear idea about what that is, how to get involved. There's no clear path. It may be a bit of a challenge that, SunPy has become more sophisticated or mature, maybe is a better word to use, that it's not like there's low-hanging issues that someone can come along and easily contribute. It's a kind of a huge rigmarole from actually making a pull request and doing all the tests and running that way. But how do we go from a student that is really actively using SunPy and using it really, really well to become a maintainer, right? What is that path and how do we do that? And I think a lot of it can be actually ownership or what people don't know necessarily, I think, the way the SunPy community works in a sense, and things I'm not allowed to just do that, am I? I need to talk to the SunPy lords, whatever that, what are you, it's not a SunPy company, but I think people, maybe it's this way of SSW where you basically needed to, someone had a key, right? You had to ask for the key to get in, and it's not like that at all. I think we had some good discussion yesterday, or maybe the day before, about, the newcomer guides is really, really good, but maybe we need a higher level thing of hey, I want to get involved. How do I start this? I don't know what this is. These are questions as I put them here. I think as well the affiliated package process is a little bit unclear unless you're already involved in SunPy. So how do you start your package to maybe become an affiliated package? And people are still a little bit confused about what that even means. So I think we've made some progress, but I don't think we're accessible as we think we are. And obviously, I talked about this last night, we had a big discussion yesterday about how can we, it's the children that are wrong, right, from that Simpsons, right? It's how do we don't know what we don't know. We need to ask people who are on the outside, what do they think, what would be helpful for that, right? Because we're obviously biased because we're already in this circle. So how do we kind of bring new people in? So how can we make it more accessible? I think we want to make sure, I think the key thing is making it feel like it's their project, right? If you are a solar physicist and you're using SunPy, you are part of the community and you have, you don't need permission to engage with it. Right. Again, I'm just reading between the lines here, but this is the kind of feeling I get talking to people is they don't feel it like it's theirs. And maybe we need to build a culture of ownership. I don't know how that looks. I mean, other projects might have done that. But maybe very interesting to have some thoughts on that. We talked yesterday as well about, there are some people that are kind of, we know we're using SunPy really well, are already a little bit engaged, but how do we specifically get them, not poach them, but really pull them in, make a concerted effort to really pull them in? Maybe identify some easy issues for affiliated packages that are solar specific that we can get the solar community in to work. If you have a user working in some type of data and there's an issue on SunKit instruments, maybe that's a way to be you're already working with this data, this is an issue you could work with, and maybe a better coordinated effort. And I guess the idea being you have a new user, maybe you open an issue, that can be the first step. maybe a pull request. Maybe then you get used to how pull requests are reviewed and you start reviewing some pull requests. Maybe you become an ambassador. That doesn't necessarily mean anything. I just mean like, again, having ownership and then maybe a custodian someday. Maybe I guess branding is something we need to work on if we want to kind of make change. Well, it really is already, but like really kind of sell this issue of it being everyone's project. We just kind of maybe need to do some branding of the community effort. And how do we do that? I don't really know. I guess maybe post more on things like LinkedIn, right? The solar community seems to have moved from that, from Twitter. And again, this is just because it takes people power. Like maybe we need to highlight new features, do blog posts, do tutorial releases, you know, like get people to write nuggets. I don't know. You know, success stories where SunPy has enabled science. We've talked about this as well, like trying to start a blog post. But yeah, I don't know. We need to think about how we do that. Some other ways we can do this is, again, it's really just getting our ducks in a row. Summer schools are really, really great. We've kind of done them before. But maybe we should create reusable tutorials so that we could then give it to somebody else and say, hey, you go give this tutorial, use SunPy, go to the summer school. That would be really, really good. I think it could be nice to have a SunPy focused summer school for more advanced users, because sometimes when you go to summer schools, it's students that have just started out and they're literally just learning SunPy for the first time. Whereas we actually almost need another one for when somebody uses SunPy all the time and then gets involved in being more advanced, like becoming a contributor, and we're kind of growing the community a bit more. Conferences and office hours are working really well, but again, I think we need to get our ducks in a row. I think we got a bit tired after COVID and doing them again and again, and there's also not that many of us that were kind of have been doing it. So maybe we just need to make a plan of what conferences are in the next 12 months, who's going to which, and kind of delegating out tasks for making sure we kind of have some presence at these conferences and chatting to the conference organizers to make sure that we have a presence there. And things that might make that easier is having like a slide deck for promoting SunPy, whether it be as an introductory slides, whether it be what's new slides, whether you're selling it to get money versus trying to get instrument team involved. Again, that just takes work, but it would be really nice to kind of streamline a lot of that. And again, going back to some of the challenges with this is that there's not that many of us that are doing this, but maybe we need to encourage others in the community to do that, where they're like, hey, I know you're going to this conference, here's a set of slides. Yeah, like exactly. So we should definitely, that's the European Space Weather Week. We should have a booth because there's also people there that might give us some money. I think, again, this is from thoughts from yesterday, like it is kind of challenging to kind of start your first issue on SunPy Core, but there's so much low-hanging fruit in the affiliated packages and simple things that can be done. It can be iterated much, much quicker. Really good for rapid development, you know, break things and then fix them again. People probably won't notice too much. There's not too much like some of the affiliated packages don't have as much, you know, it's not as stable, I guess, as SunPy Core. But in terms of doing this, like this is all well and good, but we really need to have like better onboarding and mentorship. Again, this is time and people's time. And maybe like if somebody worked on an affiliated package and did a cool thing, we need to spotlight them in their career and say, hey, here's LinkedIn posts. Like at the end of the day, if it is a researcher doing this out of their time, you would be able to, they would get something from it, and you know, maybe having it on their CV or LinkedIn post is the way to go. I think to do all these things, right, we need some money, right? Because we have lots of ideas, but a lot of us don't have the time to do this, right? So how do we get the time to do this? We need some money. So if we did have the money, we could do all this. We could develop those docs, the tutorials, the slide decks. It could also give us money to do kind of these travel to conferences, right? Because a lot of us are on our own grant money and you're like, well, I could use my grant money to do that, but also I need to promote my own science. I'm 100% research focused. I can't necessarily use my own travel money all the time for doing this. And similarly for going to workshops with summer schools. And then maybe we could buy out some, it's a little bit harder in Europe with soft money, but like could we buy out somebody's time to write some of this documentation, like I said before, and then obviously infrastructure work is always key. In terms of funding, right, we've had really good success in the past with the Google Summer of Code. In recent years, it's been a little bit more challenging. And I think some of that is, you know, maybe we need more solar-focused students that come along to do a project. I think that's a really good place, and it might make it also easier for some people to be mentors then, because you can mentor them when they already know the kind of the solar physics background and the need for it. And so maybe we could really think for next year, thinking of projects within SunPy ecosystem that kind of need some solar knowledge, and making that a GSAT project and then reaching out to potential master students, or even, I put postdocs there, but I meant PhD students, because I think you can be a PhD student and still do GSAT, as far as I'm aware. Yes.
It can be anyone, you don't have to be a student at all.
Oh, okay, well then, yes. Somebody that likes solar physics can do this. We have been, in terms of funding for SunPy, the only real money I guess we've gotten is from NASA, right? It's 2 Roses grants, with the Stoffel. And we have currently 2 Stoffel grants.
We've gotten 2, that we have a new one to replace the old one. I think there was some HD, or what used to be called the HDP that Jack got.
There was one,
but I guess still through NASA, right? And as we've heard earlier, we cannot depend on that, because that is not looking good, especially for the Roses calls, right?
And it's only can fund US based researchers, even in normal times. So
so this is great, and we'll still continue to look for these opportunities, but I think we need to look for more European support, especially because there are a lot of us in Europe, right? And how do we do that? I mean, a lot of it is just maybe on our steering committee end, we need to figure out what are the calls that we can look for. So like, is it Rise in Europe? There's some cost action funding. There's also the European Open Science Cloud. So again, maybe it's just a way of selling SunPy for doing different things. And also national funders like SDFC, which I guess you guys are, is that an SDFC call that you guys are?
COKI, I think.
Yeah. And then ESA, right? So ESA doesn't really give money for doing this for science things, right? But don't give out research grants to science institutes, but you can get contracts to companies. So they might put out a call to write software to do a thing, and maybe we could spin it that this would go through to SunPy. So just,
Does anyone have a company that could?
Are we basically saying we need more inventive interpretations of ESA's requests for
request for tender?
I think we need to.
It doesn't have to be a company. It can be an institute as well. So like DIAS, we have contracts with ESA to deliver things. So it doesn't have to be specifically a company. But I think if ESA requests for tender go out, we should definitely be looking at them.
Yeah. So I think it's just a matter of thinking outside the box, because a lot of the history of this is we're scientists, so we're used to the science funding model, but maybe we need to think about that being slightly different than what we can do. Yeah.
Just to follow up on Sam's question. The ESA contracts, are they, so like with the SSI UKRI, it's like, we want to give money for maintaining sort of scientifically valuable code, which is kind of very open and allows us to make a pick why our stuff is relevant to that broad team. But with ESA, there's we would like a specific tool that's applicable to BID or whatever it happens to be. So,
I mean, Shane was going to comment on this because I think he has experience with these tenders, but it's much more general. It's much more specific than go do a cool thing for open science, right? It's not going to be like that.
It is, except this new thing called OSIP. If you go to ideas.esa.int, it's less money. They're much smaller grants. They're maybe 50 to 100K, but they're for kind of not crazy ideas, but just it's a different way of funding things, and you could potentially get something more general in there, for research and infrastructure support of projects. So that would be a potential one, but the actual tenders that come out from ESA are like Laura said, generally more specific. But the thing is, if you talk to ESA and you talk to the right people, then you can actually get calls put in that cover a specific topic, so it's kind of you don't just wait for things to happen, you also need to go and proactively lobby ESA to do certain things.
And I think this is maybe what we need to do, is to be look, all of your solar and helium students are depending on this, give us money, or put out a contract that you can do this stuff. But we just need to be smart about this. If anybody has any ideas or creative ways of getting some money, let us know. Yes.
Is anyone in the SunPy community based in France?
There's
a recent, I'm gonna say very roughly, But so you have like the national observatory infrastructure, and then this year they're pushing hard with numerical projects. And so, for example, there is 5K euro a year that we apply to. This is like an appel blanc. How do you say an appel blanc? Like a broad net call that has to do with modeling, data assimilation, uncertainty estimation, data analysis, artificial intelligence, and it just has to fit into one of the observatories. So there is like a solar component to almost, I think, like 4 or 5 of the observatories. You also have things like this that are smaller scale. I don't know if 5K a year is a lot.
I mean,
No, but it's.
but if it helps, like, I mean, this is, you could apply for this, right?
Yeah.
The current observatory, and yeah.
Of a month.
But I mean, how much involvement is it?
For a
Because
month a year is not.
applying for that also is time. It takes time, right? So if your time spent to apply for that is above 5,000, well, I mean, I know in the US, I will not apply for that.
Yeah, but it all depends on, you know, it's a whole spectrum of things here, right? There's like a PhD student that might need 5,000 to
Yeah, but
go and work with some, yeah.
the process of
I
applying for that
I completely agree, yeah,
is expensive.
yeah,
Or I mean, that's the question. How
Okay.
expensive is it to apply for that time-wise?
yeah.
I think that you need just to write a paper that
Yeah.
describe this project and like internship or something.
And there's a much bigger one, which is 200 to 400K euro for 2 to 3 years. That is about, there are 4 themes: optimization of observational systems, interoperations of data that are heterogeneous.
So
I don't know. I can't.
what is the source?
This
of that?
is
Of the
from
funding. No, I mean the funding source for the 200K thing.
Sciences de l'univers et du numérique, the national program.
But what institution is issuing that grant?
It's INSU.
l'INSU, okay.
And do you have to be in France to receive this money, I assume? Yeah.
So, okay, yeah, I mean, I can provide something.
Friend right.
Because you were asking if there's a presence in France to, something to receive those funds. And you said yes.
No, that was my question. This, because.
Eric Bouchon.
Yeah, he's probably the closest,
Yeah.
yeah.
I'm so spicy.
Yeah, yeah. Sorry. I was gonna say, like, this is the whole thing of, you know, we're like, who in SunPy is there? There's loads of solar physicists working with SunPy there. It's like making sure that they feel like they can go like, I want to do this thing. And so Eric is
It's the same, it's same with money, it's the same thing for recruitment. Like we want them to feel part of the project.
Yeah.
That they can modify it.
Yeah.
In those grants, it's sometimes can be very difficult for having a call, someone answering this call and specifically making a proposal just to found a software suite. And what I would recommend is that SunPy, funding to SunPy gets more integrated, systematically integrated in any call related to solar, so that you basically have a regular influx of fundings, regardless of what the project is. If it's solar, then you can have always something dedicated to SunPy development. So you could have, so saying in case of France, Eric Bouchelin could advocate for that.
Yeah.
So that he makes sure, or the IAS makes sure that when they answer a call, they include a percentage of software development. And then doesn't matter where you're based, you don't need to be in France as long as the IAS has the money.
Yeah.
Once it's there, then they can issue partnerships and pay you guys.
Yeah. I think this is the thing of like lobbying, again, this is across the board, right? Lobbying the importance of research software, right? You know, making sure that's in research calls, that 20% of your budget goes to funding of research for software developers.
Is that, I heard something with that, you suggesting that the community, like when we, as individual members of the in every proposal that we add something,
Yes.
or is it like
This is
funding
one.
boards, we have to get them to state it?
Both. I think if you want to, it's better. We don't want just to survive; we want to thrive. And so I think it has to be integrated into the natural language of a solicitation of someone who writes a proposal. That SunPy must be an integral part of that language, and it has to be sort of natural. So of course, I'm going to develop some codes there, and I'm already using existing code that needs to be maintained anyway. So you do have. It would be great if any person who writes a proposal then has a commitment to software development. Then that commitment should be SunPy related.
Absolutely agree. And yeah, we can. This is just in terms of time. We can. We can. That basically finished. These are just to leave up some. We can do small term things, but I think we need to think long term about this as well. But like even just for what do we actually want to do for 2025, 2026? We can do an actual plan of doing some stuff. What summer school should we attend? Who do we want to reach? And I think what we really need to do maybe in the next little while is what does a first-time contributor need to see? Right? We're blind to this, so we need to be talking to people who are not here or newly here about what they would like to see or how they think they could get involved. So I'm going to finish it and let Mohammed speak just because we're coming up to lunch, but we can continue this discussion later on. So. I'll leave these slides.
I was thinking about simply it's all about the deep your networking.
If you're good to go again?
Code,
yeah.
So that basically, so that you don't rely on a single source. What's that? Oh, it's there. I thought you were done with the talk.
Sorry,
I'm sorry.
Sorry, first I want to apologize because my internet has been disrupted for I don't know why. But do you know which? Do you remember we stopped at?
It was very much at the start. It was the first.
The second slide, yeah.
Yeah. So basically, this work started emerged from just a coincidence observation for this interesting feature that happened during working on another paper. So that's how it started. And then the motivation came after this. Like it made me think about these questions, like what happened after the semi-eruption, and what can this rotational motion can tell us about the plasma environment there. Yeah, so we started by obtaining the data, like high resolution data from AI instrument, 12-second cadence in 6 EUV channels. And then we used these packages. I think also this work was a good opportunity to showcase but it's a good use case for using SunPy package and some of the affiliated packages like AIPy and the DM regularized version in Python and AstroPy. So first we started by inspecting the kinematics of the event by tracing the motion along this helical path. So this is how it looks like in 304 angstrom. So we divided the structure into 4 segments, and then we traced the speed, acceleration, and we fit the values here by using a quadratic fitting, and these are the initial speed and acceleration from the fitting itself. And then to see what, the distribution of density and temperature, we use the DM analysis. Okay, so we use the DM analysis, and then we like the top panel represent the lower temperature range, the middle panels represent the middle temperature range, and the bottom ones are the highest range. And we can see that the loop structure persists in across all different temperature bands, which means it has a multi-thermal nature. And for the temperature range, we see that the loops shining a lot. So we we had this hypothesis that the flare that was associated with the event have caused what's so called the chromospheric ablation, or evaporized some of the plasma that got heated and then filled up the magnetic structure. And then after the further processing, we obtained for the density and temperatures across the helical structure here. So from these maps, we defined 4 points at the same positions in both maps, density and temperatures, to trace the temporal evolution of the plasma parameters like density, temperatures, thermodynamic pressure. We also had plasma beta, sound speed, and other parameters. And in the first one, we observed that there was a time window with an impulsive heating by density enhancement. So that provides one more evidence for this hypothesis, like it was triggered by flare heating. But this behavior was not, it didn't show up in other points here. For the magnetic field estimates, we also estimated the magnetic field, which was not very, but relatively low. For the typical coronal loops, I think, if I remember correctly, it was about from 10 to 150 Gauss. So this value is very, very low compared to the magnetic field in coronal loops. But this could be due to the assumptions we have made. For example, we assume that the speed that we obtained from the tracing of the flow equal to the Alvin speed, which is not necessarily the case. There could be some projection effects because it was on the side, and some uncertainties also from the DM analysis. So the combination of these could lead to have this such low value. So for the interpretation, it looks like a sword tornado, but not exactly. They share some features, but it's not a sword tornado. And also, it's not a reforming flux loop because the magnetic field was still intact. Like it was still stable even after the same eruption, so it wasn't the same magnetic field. And also, the magnetic field, it was not twisting, so the plasma was moving along the structure, but the structure itself was relatively stable. So it was. We thought that it was driven by thermal evaporation and pressure pulse from the flare itself that filled the magnetic structure. So for the conclusion, I think, to our knowledge, this is the first clear detection of such helical flow post CME eruption, and the speed was higher than the typical speeds for solar tornadoes. The temperature was also high. So the post-eruption flows, it can be like in the form of coronal rains, or maybe rotational, or has a helical nature, like in this case. Yeah, that's basically it. This QR code for the paper, and thanks so much again for listening, and sorry for the interruption that happened earlier.
Great, thank you so much, Mohammed. Do we have any questions? It is great to see. I mean, it's a perfect example of you using the whole ecosystem to do your analysis. And I feel like I've seen you do other magical things with SunPy as well. So we definitely need to get you more involved in contributing and stuff like this.
Yeah. Go ahead. What SunPy things did you find easy and not so easy in the process of doing that? Like what bits were easier than you expected, and what bits were harder than you expected?
For this particular paper, I think it was relatively easy because I started using SunPy like many years ago, maybe I think over 7 years ago. So I already have some experience with dealing with the functions and the features. But in another paper, I had some difficulties, but it was about matching or aligning the coordinate systems. So it was basically about the different coordinate systems and the projection, like from like different projection from one coordinate system to the other. But otherwise, it was relatively easy. Yeah.
Could you tell us a little bit more about DEM reg and how you use that?
Yes. Let's share my screen again. So for the DM, I use the package is DM rig, which is I think it was developed by Ian. I think if I remember the name correctly.
Correct. It was developed by me, and I copy pasted it in by Ian.
Oh, okay. Yes. Yeah, exactly. This one.
I don't know.
Same issue.
Yeah, we talked about it already.
Yeah, so similar question as Stuart, like how did you find using this? What was it easy? Were there specific things that were challenging? Does this need to be more widely publicized? Like either things that are difficult or how awesome it is?
For the DM specifically, because that was my first time to actually get the code work, because I have tried this like in other also implementations in IDL, but I couldn't manage to do it. But this one was nicely written. So yeah, I basically used it, but maybe the documentation could be.
There's no documentation, so you're right. By definition, yeah. This is something that I probably will dedicate some of my free time to improving. We were just talking about it there in Element as well. That my version of this needs to be like properly. The repo needs to be templated. It needs to have some tests and doctrine, and then I mean already it publishes. It's all one part of that's done is that actually you don't need to use Ian's repo. You can just install demregpy, and it should work. Anyway, we've already talked about this.
So it's not.
It's well, I mean, it's very, very difficult to test numerical. It's smoke tested in the sense that it's tested to run. It runs, but it's very, very difficult to write
can't test it
numerical stuff without a ton of effort. Yeah, you could do regression tests, and we could also test like chi-squared on known. Like we have a known, like if we put an input a known DEM, and then get it to output via a bunch of different techniques that you've got available to you, we can check that the chi-squared is reasonable. So there are.
This could be a very, very good case. Yeah. Is it? I don't know. But maybe this could be a good case if Mohammed was interested and willing to write an example gallery that could live on this documentation as like a first step of contributing if you want to.
Yeah,
I think even simpler is what you could do is write. If you look at some gallery examples in SunPy, you don't even have to build a gallery, right? Because the gallery doesn't currently exist. So that's asking a lot of you. But if you look at SunPy gallery examples and see the format that those files are in, you know, with they've got like markup as well as Python code, and take some, if you can find bite-sized aspects of your work and put them in that format, then at some point in the hopefully near future, you can then apply that to demregpy's gallery. And we're talking about, you know, I think we're talking earlier about more tightly integrating demregpy into the SunPy ecosystem, not necessarily as an affiliate package, but you know, and so that effectively that would be really useful for us.
Yeah, that'd be great. Okay, I guess it's lunchtime. So thank you so much, Mohammed, again, and to all of our speakers. We will start back again at 2 with the State of the Union. Yes, thank you all. Good night. No. Okay.
I can have that some.
That word does remind me of my great big thing that
Yep.
Yeah. I can hear Stuart if you want me to do.
Go for it. Go for it.
These are them right, Albert?
Yeah.
Of course.
It's a great moniker. Okay, so of course I've managed to do some neat things over the past 2 years since our last quarter space meeting of this type, and so Stuart already touched upon some of the recent changes, but here's everything that I wanted to highlight. Next slide, please. So this is an interesting one because I was reflecting upon this yesterday when we were talking about the roadmap, and one could have imagined that there'd be a roadmap entry for having some kind of level of SPI support, depending on the scope and the nature or the future looking at the roadmap. And it turned out I wrote this in like a week, right? So some things it can be hard to tell maybe ahead of time just how hard or how easy something is. Sometimes you just have to roll up your sleeves and just try for it.
Yeah, I think the key word in that sentence, Albert, was that you wrote it in a week.
Yes. If this were a GSOC project, it would have taken a whole summer at least. There's just there's a lot of fiddly parts and a lot of trying to come up with a good API like very, very quickly. Like I had to make a lot of decisions, right? As opposed to if it was someone else doing it, I would have really mucked with their decisions. Also, an important factor. But we do have SPI support. There's some discussion at some level of upstreaming this to AstroPy. I just don't have that in my bandwidth to really explore that, but it may happen. But it does give people the capacity to actually interact with SPICE kernels. So at least it's there. And I know Laura uses it sometimes, so I'm glad it's getting used. Next slide. This one I want to highlight because it's also an interesting one. There was a comment, I think, yesterday about how we're doing a little more non-sun things, perhaps. I decided at one point I was a little bit, I don't know, peeved is the right word, but a little bit annoyed at the SpacePy, having to jump over to SpacePy to get some of the Earth magnetic frames. And it also meant that our one hook through SpacePy is through Geo, through ITRS. But that meant that we are kind of trusting them to do the rest of the transforms in a way that was consistent with how we would do things. So instead of doing that, I decided we're just going to implement these 3 frames: geomagnetic, solar magnetic, and geocentric solar magnetospheric, which are awful names. But I implemented all 3 of those. And now that means that we actually have quite a few frames with which we can, in principle, do comparisons with other libraries to see how well we agree or how well we disagree. And this also feeds into, as some of you are aware, there is a low level of coordinate group, coordinate, I don't know, the working group, I don't know what the right term for it is, but Bob Weigel is really trying to understand how all these different packages disagree with each other. But this gives us at least more of what I say here, a surface, more points of comparison for which we can say, okay, we're doing this stuff, this library is doing this other stuff. And especially where some of the times that some libraries may not even do consistently, like a geo to solar magnetic, they may not agree with us, and we can try to understand why that's the case. Okay, next slide, please. Stuart mentioned this in passing. Helioprojector radio has been a very long time request for SunPy, and finally we made it happen. I made it happen. The main trick with helioprojective radio, which is something that still is a little awkward even in this implementation, is that the impact angle, the angle from sun center out radially, is kind of an awkward component and has to be stored in the FIT standard with a 90-degree shift. And so that kind of handling gets a little clunky. So what ends up happening is we deal with it in the context of the FIT standard, and then I provide a helper that lets you modify the display of the component on such like this plot on the right to shift it by 90 degrees and have WCS axes display the component that you actually want and not the 90 degree shifted component. So it's a little bit of contortion to actually get it to happen, but it does mean that we do support any helioprojective radial FITS file, and people with those contortions are able to do all the transformations and display that they might want. I don't know how much this is getting used, but certainly if when people actually use it, maybe we'll get some feedback on how to make it more smooth.
It'd be super nice to add an example with a coronagraph as well as a full disk image.
Sure. Someone do that.
Are these what people call, like what do people, I see these maps sometimes, like, do you call them something different? Is it like
It's called like, not JMap. JMap is like you have to slice. You have basically that you have to be like straight instead.
So you take a slice from the.
Take a slice and then.
Yeah, well, but they make JMaps from these, right?
Not sure.
Oh.
I think JMap is like you have to take a slice from like a chronograph and then you have to plot it two times. But I think like I produce like similar maps on this, but I think what is it called? Polar projection or something like that. I don't remember. But I think this is very neat. I think this is very neat already.
Yeah.
Yeah, I think my one when I do it is much more clean.
Yeah, actually, you do this type of stuff a good bit, right?
Yeah. Yeah, that's like the type of stuff which is a lot more clunky than this. But I think this is probably going to can be used to adapt to use forward. Yep. But I think in my case, I normally, instead of impact angle, I use like solar radii directly. Because that is just like my use case, but yeah.
I will say that as a stopgap, before this was actually fully implemented, I did give people, there was a post that I would point people to where I showed how to do something similar to this by doing a kind of creative WCS projection with specific origins and definition. So this was technically possible for a while to make an image like this, but this at least now is in a much more consistent with everything else kind of approach. I will say also this plot is a true reprojection, like it calls reproject the package. In principle, some of the later stuff that I'll show with auto align, like you can make an auto align version of this and actually preserve the original pixels, which is actually also kind of cool. But I have not actually tried to do that. But it gets a little weird when you do this, right? Like why I say this, and you'll see on the next slide, I think, that like the pixel at the disk center actually gets stretched out quite a bit, but in the reprojecting, it's all pixels. Like it's split up into the output pixels, and so you're over pixeling kind of the center pixels, but you're under pixeling the outside pixels. There's just it's not balanced because there's such huge distortion in the pixels, in the original pixels. So next slide.
Presumably,
yes.
using one of the other reproject algorithms would do a better job of handling that than
No, I mean it's not about the accuracy. What I mean is about the computation time. You're wasting a lot of time. Like, if you want to get the full resolution at the finest pixels, you have to have a very fine output resolution. But that means you're way oversampling the coarse pixels.
That's fair. Yeah.
And so you're wasting tons of computation time. So it's an interesting difference, and it's kind of touched upon here too. So people know that this actually held up 7.0 in some ways, but I did a huge flurry of activity recently on auto alignment plotting. Auto alignment has been around for a while in general, and I'll just highlight the first bullet there. Auto alignment is not the same thing as reprojection, and this is something kind of my evolved thinking. I really should write this up as an explanation page in our docs, but auto alignment is about displaying the map's pixel data in a different representation, coordinate frame or WCS projection, by basically conceptually plotting each map pixel as an individual quadrilateral, essentially. Whereas reprojection is where you actually define a new pixel grid, and you're transforming the original map pixels to that new pixel grid, and then you display it or whatever you want to do with it. But reprojection, of course, is just getting a new data array. Whether you plot it or not is up to you. And so it treats the native pixels differently. And so it depends on the use case of which is desirable. But in the case of plotting your data, if what you want is plotting, the first is arguably more preferable. Now, auto alignment plotting until a few months ago was kind of painful, kind of slow, especially when it came to interactive plots. And it turns out that it had to do partially with some unnecessary computations the way that we're using Matplotlib. So we do the pre-computations outside of Matplotlib and just tell Matplotlib or feed Matplotlib something that uses a lookup table. Then everything goes a lot faster. It goes faster by at least a factor of 4, and for interactive plotting, even faster than that. And so that was already the first step towards making auto alignment plotting tolerable. And then on top of that, we also implemented an image-based auto alignment. It used to be a mesh-based auto alignment only, which meant each pixel we plot as a quadrilateral. But for lots of transformations, you can actually use Matplotlib's internal way to kind of contort an image, and you can use that to plot even faster, possibly. I say possibly because it actually is a little bit tricky about which is actually faster than the other. It's very case dependent. But if the image works and if there are more than a few pixels in your image, then the image base should be better. So then after a bunch of back and forth, we decided to make auto alignment the default behavior. And now our plotting is essentially coordinate aware. So not only is it coordinate aware in the sense that if you plot it on its own axes, it looks right and shows the right coordinates. But if you plot it on a different WC axis with a different coordinate frame or a different projection or both, then it will just plot the right way. And since it respects the native pixels, you can see on the right what happens there, where it's a little hard to see, or hard to tell necessarily, but if you squint, you can start to pick it out. The top image shows a rolled AI image. It's our standard sample image, but made coarser so that the pixels are more obvious, super pixeled. If you plot with auto alignment to de-roll by whatever that amount of roll is, de-rotate, you can see that in the auto alignment, the edges of the map are completely straight. The pixels are all preserved, just everything is turned. If you look at the pixels individually in that middle panel, all the pixels are kind of turned a little. They're no longer, horizontal and vertical on the edges, but everything is preserved. Whereas if you do a reproject, the bottom panel, you're reprojecting, you're transforming to a new pixel grid. And so everything has to conform to a new pixel grid. And you can see that each of the pixels along the edges, now you have a stair step pattern. And then if you look at where the active regions are, you can see the active regions actually look a little bit different because you've actually now modified the pixels. So that middle panel is now what we do by default. We do the auto alignment plotting. You can just plot anything on anything and it'll just do it. With the new increases in speed, it is mostly, it is usually tolerable. I imagine if someone's plotting a whole ton of images, they'll notice the difference. But for one-off images, it's actually kind of, you just blink a few more times and then it'll show up. But it is actually faster than lots of reprojection possibilities. It depends. It's also case dependent there. But again, reprojection forces you to a certain pixel grid, and so it can waste computation time in a way that auto alignment does not.
So it doesn't change anything if you just have one map and you plot it, right? It's just only
if you plot it on its own axes,
yeah,
it'll essentially internally use image-based auto alignment, but then it will see that it's on its own axes, and so it'll just plot. So it technically goes through a little bit more of a code path, but it barely.
Okay. So just from like a user point of view, you would just not put auto align equals true anymore. That is just by default. Is that the?
Yep.
Okay. Cool.
Yep. That's right.
This works for sort of more exotic combinations of WCS, I'm thinking I'm thinking of your helioprojective radial on the previous slide.
I don't show it here, but yeah, the helioprojective radial, you can absolutely just do that. You specify the WCS, in fact, this is what I did for this one. I took a derotate, and I think I did the reprojection to that, and then I used that same WCS to just do the auto alignment. So the same way for the helioprojective radial one, if you have a WCS output that you want thing to be in, but you still want to display the native pixels, then you appropriately transformed or reoriented, then you can just do an auto line, just do the normal plotting, which will do auto line equals true by default, and then it will just show up. It's all pretty seamless. Back when I did all line in the first place, I showed stuff like, you can do a differentially rotated map, or you can take like a HMI sharp image and just like plop it on the sun. It's just the auto alignment is really great for compositing, where you already have something, you just want to plot another thing on it, and then it's compositing done right.
That's really nice.
Okay, next slide. And this one is a little bit on in the crazy sphere, but Will's actually used it quite a bit. So first, screens. People are mostly in this room are mostly familiar with screens. It's a design choice on our part where we refuse to assume anything about off-limb points and where they are in 3D space. And so when it comes to AI image, like shown on the left-hand side, those points, those coronal loops off to the side, we say we don't know where they are, how far they are from the observer. And so when we reproject, we normally say that we can't assign a 3D position to them, and so they will disappear upon our reprojection. And so the solution to that choice is to then allow the user to be able to insert an assumption, and those assumptions we call screens. And we say that, okay, you can assume, historically, you can assume a spherical screen where you say that it's centered on the observer, and a screen, imagine a conceptual screen running through the sun center, and that's where the coronal loops are actually lying. And then reproject based on that. And on top of spherical screen, and then we recently added planar screen, which actually has slightly better stability, but may or may not be more intuitive. The big change recently was, and this was something I've been off and on thinking about for years to try to fix, was to try to get this screen functionality play nice with solar differential rotation. And up until a month or two ago, it did not play nice with solar differential rotation. And the reason for that is really hard to figure out a stable way to define where the screen was after it differentially rotated. And I tried stuff like using a ray tracing, a Python package and stuff like that to try to figure out how to solve for it. It turned out to be a real pain in the butt. But I came up with a pretty quick stable approach that just numerically solves for where that warp screen is. And it works pretty well. You can see on the right here, the screen has now been warped by 5 days. I didn't fix the labels, the overlay, the tick labels there, but rotated by 5 days, and the spherical screen has been rotated and distorted as well. And so this is, anyone working with solar differential rotation can now at least have some way to preserve the off-disk information. Of course, if you rotate it by enough, things start to not make sense, but that's, so be it. I mean, you're just trying to make the best of things. Most of the time people use screens are not for such severe rotation, of course. Most of the time people use screens are for when, they want to rotate like an hour or something like that, or a day. And at that point, just the fact that the screens will now work to preserve the off-disk data, I think so can save a lot of people's sanity.
Just to ground this a bit, because I feel like this image in here looks crazy. It's why would you ever want to do this? But
that was going to be my question.
Yeah. My use case is that I've been looking for ice rasters of active regions that have persisted across multiple rotations. So I'm looking for intersections. I know where the active region was at disk center, but I want to know whether there's ice data available within plus or minus 5 days of when it was at disk center, and then repeated over multiple rotations. So I'm looking for intersections between bounding boxes over long periods of time. And so what I'm doing is I'm taking the nominal ice raster bounding box, and then doing differentially rotating it forward and backward in time to try to see whether it intersects where the active region I know appeared at disk center at a given time. But some of those bounding boxes are just slightly, they might have one corner that's off disk, and so then you get one coordinate that's NAND, right? If you don't have a screen, but you want to differentially rotate the whole bounding box, right? And so in order to do that, you have to assume something about the offload points. And the only way to combine all those things was this PR. Like, it's a really subtle thing that's annoying to deal with, and especially before this was, more that you couldn't do.
Yeah, I mean, your case especially is exactly why this is useful, right? I wonder whether there might be there may be a way to cast out like a showcase or something to make it clear, like, this is how, if you encounter a situation like this, we can at least point people to a gallery example to say, yeah, if you want to differentially rotate a bounding box that goes over the solar limb, this is how you would do it.
Even just slightly, yeah.
Okay, next slide. This is just a rapid fire. Other things I just wanted to point out in the past 2 years. We did some solar eclipse stuff. In some sense, that just showed that the coordinates actually work. Some helioprojective has a method is visible to help people know whether it's on the front side of the sun for an observer or on the back side. Drawing extent of a map on, or WCS on another map on a WCS axis. That here I show one of the examples from a gallery example there on the right. And then the reprojection with the automatic determination of extent. This one is handy, and of course, as Stuart has mentioned, it could be it's useful to think of this beyond just a 2D map. But what this will do is means that you don't have to know ahead of time what the extent of your output should be, but you can instead just have your WCS header for your output WCS, just at least get the coordinate frame of projection right, and then it will do. It will try to figure out what is the actual extent it needs to contain all your map data. Now, it doesn't actually know. It's not magic. You do need to specify whether it should be making that calculation off of just the corners of your initial map, or off the edges of your initial map, or off of every single pixel in your initial map. But even if you set it to using all the pixels, that one calculation actually doesn't necessarily take all that long in the scheme of reprojection, just to determine just what are the bounds of containing all the data. And it means that your output map will not only contain all the data from the original map, but also not include any pixels that it doesn't need to contain. And so it can be quite a bit faster as well than, like, previously you might do a reprojection to a much bigger canvas than you necessarily need just to make sure you caught it all. But then you actually waste a lot of reprojection time as reproject goes through every single pixel and decides it doesn't actually need to put anything in each of these pixels. So again, the auto extent probably for certain use cases actually is faster than the conservative approach of just having an oversized target map, target WCS. Next slide. I think this is my last one. This is just highlighting, this is not a roadmap per se, but stuff that's kind of on my to-do list, or the more significant things on the to-do list. We got to get rid of the old way of doing differential rotation. It's been hanging around for a very long time. In fact, I think it might still have some documentation strings saying it's experimental. We really just need to bring it down to just one method in existence, and then even for consistency and the future maintenance, it's the way to go. Especially with the auto extent now, the main thing that kind of was still nice about the old way was that it did do attempt to calculate the extent, but now with the auto extent and reproject, it's not even necessary. We do still need to improve a lot of coordinate performance where we can. We did add there's now, with a label for your PR, you can turn on the ASV, the airspeed velocity benchmarking. But that benchmarking still, it's a little bit unfortunate where the benchmarking, there's a lot of noise in the benchmarking. And so for the coordinate stuff, it can be a little hard to tell whether you're actually getting improvements or not, because sometimes it's just, there's enough fluctuation in the benchmarking that it's hard. The coordinates, you're kind of clawing for like a few percent improvements, and sometimes the noise is like the 10-15% level in terms of the timing measurements. And so it's a little bit frustrating. It isn't super helpful all the time to tell whether you're making small improvements. Some of the handling of 2D coordinates would be nice. We still have to go through assumptions about 3D for some of the transformations that could in principle be 2D to 2D. And then really, this is a big venture that I kind of want to would like to do. The internals for coordinates are still. When I did my major overhaul many years ago, I did improve things, but still, it's still a little bit more piecemeal than it needs to be. We could envision a much more uniform structure, perhaps a la Spice, to which to handle a lot of the transformations, and with a possibility of giving some benefits of better ways of handling vector fields, or to also kind of avoid some of the finite differencing that's done when it comes to velocities. This will also be useful to make it perhaps a little bit more tractable for some future person other than me to actually take over the maintenance of it. And then I kind of hinted this before, but we really still have to figure out, like, quote unquote, who's doing things right when it comes to coordinate transformations, or whether there's ways we can improve the accuracy of things. But as it stands, I think out of solar packages, I think we're probably doing the best of anyone. I'm not biased at all when I say that, of course. I think there's still parts of it that maybe when it comes to when the solar crosses to astro or crosses to geo, that we may not be doing things quite as well, or at least quite as consistently as we should be. And that's still an open question about whether there's things we can do better there. Okay, I think that's it.
Great, thank you so much, Albert. Does anybody have any questions or comments or thoughts? Oh, thank you, Lord Accord. Yeah.
Does the differential rotation with the screen assume that the screen is rigid above the solar surface? I assume it does.
Okay, so that's an interesting question, and there's the design choice there. I did float this in Element, but maybe we should create an issue about it. So what it currently does is not necessarily intuitive, but what is the right answer is also not necessarily intuitive. So when it comes to a point above the solar surface, what our code base does, screen or not, what our code base does for solar differential rotation is it bases it on the latitude of the point. And so if you have a point that's really close to the pole and really far away, it's the latitude of it at the sub point. Like if you take whatever point it is, you draw that all the way to the solar center, where it intersects the surface, that latitude, that is the rate at which it differentially rotates.
Okay.
Which it really depends on like what you expect to what you think physically makes sense for a point above the solar surface. So I floated this an element, like we could have it where it is like that. We could have it where it's really cylindrical shells rotating. We could have it where it's circular discs stacked on top of each other rotating. Like those three, there's arguments for all three of those about which way it should be. But right now, we just do what is actually just the current framework, where it all looks at is literally it looks at the latitude component of the spherical representation and bases it on that. So for some use cases, that'll be fine. For other use cases, I mean, that's great if you have like space elevator like kind of a radial thing that's coming straight out of the sun, right? Like a spike. But if you're talking about something that might really be respecting cylindrical shell rotation, you know, it really should be something else. And maybe that would be another context manager to define exactly how you differentially rotate off the surface of the sun. I don't know whether that's even worth it. It certainly is a minor detail for the kind of realistic use cases that people would.
No, 100%. I was just more curious than anything.
Sure. No, it's a very good question. I was. Like I said, it was something that I was like, this is interesting behavior once it starts to get near the poles about how it's handling things.
Yeah. Anybody else have any other questions? Maybe it's a bit of a hard question. Yeah. How do you envision, Albert, like, you know this stuff so well, below it kind of well, but like, how do we make this sustainable if you, not, like, please don't disappear, but if you disappeared, what would happen, right?
I hinted at that when I talked about refactoring the code to try to make it a little bit better for some future person. It is, technically readable right now. People like Stuart have actually looked some at the internals and can probably can shoulder through it. But it is a problem. There is a bus factor here. There's some parts of it that I'm sure that someone really is not going to be able to understand it, and so we do here and other places in our code base, but here particularly, it would be good to have some kind of transition slash mentoring slash continuity of understanding, and I don't know what way to approach it. And part of the problem is there are parts that I know are hard to wrap my head or for someone else to wrap their head around, but there are parts that I may not realize that I may think are easy to understand that people just don't get, right?
Yeah.
And so that's where we really do need to be thinking about, and throughout our field, we need to be thinking about this kind of thing where if someone here or someone up and coming is particularly interested in coordinates, especially maybe someone who is perhaps like SPICE educated already, but even not necessarily that, just someone who just has a kind of a penchant for this kind of thing. I can start just talking with them, and we can have some kind of like maybe some sharing of knowledge that might help insulate us from any kind of drastic situation.
Yeah. I wonder, like another coordination meeting, could we just have a day or an afternoon where we all sit down and you teach us the ways? I don't know, like we go through it together. Or so, document it from, I don't know, an idiot's guide to the coordinate stack. I don't know. Yeah. Maybe, I know that's a lot of work anyway. Maybe just something to think about how we would approach doing something like that.
Yeah, I mean, it gets the main question is that there are parts about the SunPy implementation that are tricky, but of course it also has a lot to do with understanding AstroPy too, right? You can't look at just the SunPy code and be able to wrap your head around everything. So it could be quite daunting for as an education. Like there's going to be a whole AstroPy component, and then there's what SunPy does on top of it.
I can read the code and I understand how it's architected and how it's put together. The thing that takes me the most time when I get into it is the actual maths of the coordinate transform, coordinate transforms, and what what the coordinate systems are, how they're defined, how the transformations work, what linear algebra is, that sort of stuff.
Yeah, I mean, and that's part of where my conceptual refactoring can make that a little bit easier. Like right now, like one of the big changes I did back when I did a huge overhaul was at least try to talk internally a little bit more in terms of rotation matrices, so that a lot of the code looks similar, like when it comes to each of the transformations, but it's not brought together yet in a much more kind of easy way. Like SPICE really is structured where it says like, oh, this is the orientation matrix, and then just run through everything through the same code. And so that's where I would like to kind of nudge the SunPy code to, where like you basically like each of our frames, at least, if I can't get AstroPy to do this, at least SunPy to do this, where each of our frames, we define a primary axis, a secondary axis, how you compute those, and then it produces the orientation matrix. And so this might be, it could be like a generated thing, or it could be an on-the-fly thing or something, but basically have some kind of dictionary for each of our frames that makes it possible such that it separates out, like this is the frame definition and this is the code given the frame definition, right? So that people can maybe understand it that way, where like you don't have to understand why, you don't necessarily have to understand, sorry, you can look at the code and say, oh, if the primary axis is this and the secondary axis is this is what it needs to do. You understand the math in that context. And then you can argue all you want about what the definition of a frame should be, but that's a separate, argument, and then it just comes together in kind of a building block way. That's kind of my vision of how I would like to kind of nudge things towards, because I think kind of long term that would be easier than someone like looking at some of the transformation code, which is again, it's structurally a little bit structurally cleaner than it used to be, but a lot of it gets repeated, and so people looking at it might say like, "Oh, is this the same or not the same?" Or like, why is it done this way? Or is it just a copy paste of this other thing? Getting rid of that repetition would be a huge step toward making it feel a lot more accessible for people to wrap their heads around.
I mean, and as an exercise, if you do want someone to get to know it, like you can just ask them to like re-implement an existing coordinate frame pretending it doesn't exist, because then you get a really good handle for what has to be done essentially.
I mean, on the stick side, you guys have done some coordinate stuff.
Yeah,
for sure.
How's
that felt?
It's just it's a lot of surface, like you say, because you have to know like the SunPy side of the coordinate stack, then you have to go to the AstroPy coordinates side of the stack and make sure that you understand that. But it wasn't too bad. it's just some of it's when you first come across it, it's just a lot to load into your working memory.
Sure. Yep.
Great, thanks, Albert. Yeah, I guess we'll move on. Now, Nabil, when you said don't worry about it, does that mean you're going to actually talk about it? Or should I just not worry about it?
Don't.
Okay. So potentially,
Nabil might worry about it.
Yeah. So I think what we're going to do now is potentially Nabil's going to talk. Is maybe trying to share a screen. And then after that, we will start our lightning talk, starting with Carla. But we'll see what Nabil does. I'm starting to worry. No.
You shouldn't be worried. Just worry about it.
All saved.
Attention please. We are about to carry out a test to the fire alarm system. Please ignore the following alert. Thank you.
Okay, we're going to, you heard.
Good, thank you.
Actually,
I don't think it actually
I think
muted.
it's now unmuted.
yeah.
Son of a bitch.
You have to hold it.
Just stand there.
Can you mute it on Jitsi with that?
I don't think you're muted still.
What?
Rough.
Yeah,
Oh, I thought it was interesting.
That's what this is.
It's
doing it in real time.
Can everyone hear us?
Yeah.
I think we're double unmuted now, so the fire alarm is finished.
People online hear us?
Yep.
Yeah.
Okay, I've got 8 minutes, so I'll be quick. So I just want to give a quick overview of the affiliated packages. So for people who aren't aware, we have a list on our website. Oh man, of every kind of Python library that has approached us, whether it be from external contributors or packages that we've developed internally for our own research or purposes. We have a review process. There's a issue open for another package that someone needs to look at. Thank you.
With the community role of affiliated project, affiliated package is supposedly Will, but presumably somebody else would be, if anyone is interested in shepherding the reviews, then that would be a good thing to volunteer for.
So I'm just going to cover some of these packages specifically because we've already covered DKIST, NDCube, SunPy. So I just want to give a quick overview of like what the status of the packages, things that have come out, some issues that we have with the packages, obviously being maintenance and not enough people. So I'm going to go through my GitHub list of repositories I've just opened up. So first one, obviously one I look after is IRIS-Pi. So this is part of Lockheed Martin's Space and Astrophysical Laboratory for the IRIS mission, which will probably be taken out and shot in 18 months.
That long?
That long. Well, the day Muse launches, that's when the budget zeroes IRIS. So I've been so internally, we have three-dimensional data cubes. So we've been using NDCube, we've been using GWCS, mostly the DKIST modeling because I have rastering coordinates and I need a way of representing all of that. So from at least the users that I work with, there's been problems with spectral fitting or cropping or people just want to use maps. So I've just been literally adding features. So that's what these changes are. And obviously, I'm going to steal his thunder. So this is the spectral fitting thing that he's going to showcase at Hanode. But I did it first because it's in my library. So this is just fitting a three-dimensional raster cube on read the docs, single-threaded. It's like 40 seconds. Incredible, right? And these are the fitted moments from Albert obviously has found some interesting bugs. There's some interesting bugs here with GWCS. So that's me trying to contour the AA image on the left onto the IRIS image, and as you can see, it works flawlessly. There's a tracking issue that Albert found and he's opened on SunPy. So yeah,
exactly what you want.
So some very funny bugs over there. Close that. No one cares. Why is this even open? Okay. AAPI. Oh, beautiful. Did you write that, Albert, or did someone?
Tom's on a bit of a WCS axis.
Beautiful. Okay.
He's been squashing the bugs.
Yeah, thank you. Somewhere thanks to Tom. The other packages are obviously AAPI. That has not really had much changes because it's relatively stable. Things missing from that are like IDL comparisons for like PSF calculations, which was on the do list. When the JSOC went down, we had to rewrite a bunch of code because we'd assumed the JSOC would never go down. It's a terrible.
Potentially flawed assumption even under normal circumstances.
The things that we were using it for made sense.
Yes.
We would not expect them to be unavailable for long periods of time until,
This is like updating the pointing table or like the calibrations, like accounting for the degradation, like reuse. There is a canonical source that is a JSOC. It being down means, so we have to like implement workarounds and like upload random text files which had all this information that was outdated. That was a fun little.
I will say the biggest outstanding thing on AAPI is adding the temperature response functions, which God damn it, if it takes me till the day I die, we'll do.
Until AI has long since died itself.
What is it?
Very open.
Well, if you're working with this AI data from 35 years ago, now the temperature responses are implemented in AAPI. And with this, my life's work is complete.
Yeah, so then it comes back to. So, for context of that, as part of SunPy Instruments, which is where we dumped all of the old instrument code, mission-specific instrument code that we are unable to maintain directly because we don't have the necessary prerequisite information. Within here, this gentleman wrote a class, an X-ray class, or a class that uses X-ray to represent channels of instruments, and the goal is to, with SunPy, eventually, hopefully, combine everything into one beautiful.
Yeah. I think more importantly, what we did, there's like, it's an abstract based class for implementing like the idea of like, if you have, for example, an imager and you want to do like an effective area calculation, it's like provides you like a framework for expressing all the components of that effective area calculation. And then, because not like ideally, right, you have a bunch of different instruments do this like temperature response calculation very similarly, or just like wavelength response calculation really similarly. And this provides like a container for that, plus the like assumed solar spectrum. You would combine that with to get something like a temperature response. The other component is that we came up with like it's not really a spec, but like a pseudo spec for like a vocabulary, I guess what you would call it, of like what all these things mean. And now this is a topic guide in the docs. With the biggest problem being like when people say effective area, or when people say wavelength response, or like, and all the components of that, they often mean different things and with different units. And so this is just an attempt to like standardize how you talk about those kinds of things. So there's docs, and then there's like an abstract implementation of those docs. I would not call it a spec, but it's vocabulary. And so it's like if you come along with a new imager, or a concept for an instrument, the idea would be you could use this, and then the way in which you compute like temperature responses is the same for all of your instruments.
It's 1 minute left, so should I stop and then we go to talks? Or?
Yeah, I think Jerry have a few more minutes.
Okay.
Yeah.
So what I say generally about all the affiliate packages is that for the most part I've been ticking the CI along. If there's any like maintenance updates, I've been releasing them somewhat regularly, not always. So that's why you see all these releases. Like, not a lot happens on these packages these days, but we just want to make sure that they're still functioning. Oh, I've lost my VP on. It's back. Give it a sec. Come on, Jitty. You can do this.
Yeah, but I need to refresh the local. It's not mine today.
Just do that again. Second time's charm. So we have a 3D visualization package that David wrote and a GSOC student. I've been trying to keeping that maintenance. It's fun because that relies on VTK and other packages, and apparently that is now segfaulting on Linux. Only on the CI though.
That's actually I didn't realize it was VTK. That's happened before with a different package that uses it.
Yeah, no, I think I isolated down to the pipe Vista, which wraps VTK and segfaulting. So it's calling something is way there. So there's some maintenance here. People actually really want to do 3D visualization, so we've got a bunch of pull requests, like opening like a new Cartesian plot. Someone opened like, oh, I want to plot a current sheet in 3-dimensional space. This is all being on like for me to review, and I haven't done that. So, but yeah, so this gentleman has these like really interesting, like SunPy maps, that kind of thing. Like that's.
I had a quick look over this the other day and have another look.
You had a quick look over it and decided it was the Beals problem last week.
Well, yeah, so I think this comes to a point where, as Laura was saying, our onboarding process needs to start pointing more towards the affiliate packages as places that people can like, oh, you want to learn, you want to have some fun. The code is generally simpler. There's less of it. You can start here. So I think that's a onboarding documentation problem. We have the MPR animators, which is just a way to animate ND cubes. Not ND cube, but n-dimensional cubes.
Yeah. More than that, it is a way of interactively animating anything.
Yeah.
The base class of that is here's a matplotlib axes object, and here's a function that changes it, and you can have functions for any number of sliders or whatever.
I think the example gallery for MPR animators is probably the least interesting. It shows the least useful examples of what MPR animators can do, because it's just like, oh, here's a map. Oh, you want a sequence of maps? Oh, congratulations. Like, it's not. I think it's an open issue for like more examples, but.
And again, I think that's a really good induction in, right? Because there are simple things to do. They're usually what people are using it for anyway. So just need to reach it. So.
Can it be used to? Remember, we had these ongoing issues with the cross-fading maps. With whatever was used to do that, is it not a massive nightmare? Who remembers what that is?
You mean,
MPL Cairo.
Yeah, so Albert wrote an example in MPL Cairo to do that. That's in the SunPy docs.
Could you use this?
No.
No.
I think you could probably, it's a good question. Like, I don't know if you could integrate them together to do that and then animate.
Because it'd be nice to get rid of.
Yeah, unfortunately, that's not going. We had to push them to update their wheels.
I know, it's always a constant pain. Well, not constant, it's an occasional pain. But
I'm trying to skip.
Did you come up with some other insane way of doing the wedding that didn't use Cairo?
I think so, but I don't think he liked it. Did we keep that example, Albert? Do you remember?
No, we got rid of MPL Cairo.
Oh, right, we actually replaced it.
Right.
Okay, we replaced it, yeah, okay. I prefer MPL Cairo, but that's
Cairo was nice, but at the time it was too much of a headache.
Okay, so NDCube, we've already talked about NDCube, but I think we'll talk about, that gets releases, fixes. Danny, if you want more information, Danny can talk about that.
There'll be a 2.4 relatively soon with ASDEF support.
I'm going to refer to you when I get to that part.
Delete some raster, no one cares. So SunPy Soar, which is our plugin which allows us to access the Soar archive. Well, actually, we don't say the Soar archive because.
Well, while we're talking about this, I just wondered what people's opinions about merging this into core at some point are now, another year or so on from last time this topic came up.
Merger.
Yeah, I'm a yes as well. I think all the Fido clients really.
Do you think that this is both the code and the service it's interacting with is like stable and well polished enough that it deserves, like, belongs to being core, right? Is the code and SOAR itself like as good as the VSO, right? Like we have that in core, right? Is there?
It's better than Helio.
I guess
Anything is better than Helio.
I guess
Helio's a load in.
like there's two things. I think having the base function that it does now in core makes a lot of sense. If we put it into core, there's a lot of other things you could do with querying different databases on SOAR that would be really specific, and you wouldn't want it in Fido, right? But like majority of people would not be using those, so you could still have a SunPy SOAR type thing. Maybe we need to scope that out in terms of. I think in short term, it's just the way it is now in core. It would be stable, and the Heliophysics archive people at ESA are like really keen and happy to work with SunPy and make sure that that is stable for that reason.
Would you consider it the same way that DRMS? So we have the JSON client, which is DRMS.
Yeah.
So you can access, if you want to do like really complicated or like other things, not through Fido, you can access the SOAR client directly. And like you point people, okay, if you're doing straightforward SOAR archives, SOAR queries, here's how you do with Fido, and then okay, you actually want to do this like really complicated, like not and like SQL query, like okay, here's the actual client, here's the search.
Then make a dependency on SunPy on it, and have SunPy examples handle Fido-based queries, and have SunPy SOAR docs handle more complicated queries. Is that what you mean? So that's what DRM is?
No, so
But there's not like I haven't looked at SunPy SOAR in a long time, but there's not that like layer, right? There's not that like the Fido client doesn't call something else underneath. It just makes the request itself, right?
Yeah.
I think there's plans to move to the tap client, isn't there, Laura? Because you can do really fancy queries if you use the tap client rather than kind of manually doing the URL stuff.
No, but it is using the tap client.
No.
Partially, still accurate.
No. You just URL strings, which probably hit the same endpoint, but it doesn't have the functionality of like generating all the table names and stuff like you can do.
The JSOC student tried, and then we hit an issue with AstroPy tap. I forget if that API wasn't in the situation where we could do the kind of queries we needed to for the SOAR. There was a closed pull request with this implementation, and I forget the actual reason, but there was some barrier that we couldn't replace with actually by tab.
Maybe it sounds like this is gonna have to be kicked to can again.
Yeah.
I think we should definitely actually have another discussion about this. Maybe we can talk about this after.
Sorry, what I'm referring to is that we have an example in our tutorial about, oh, you actually want to make a more complicated query to the JSON. You call this JSON client directly.
All right.
Whether or not, yeah, right there. Tutorial, acquiring data, funding, making query, client or search. We've had this for years.
Yeah, why?
Because people.
Oh, I think because of the staging thing. If you want to, it can't.
Yeah.
It's, yeah.
There are, so I think for sorting, here are the simple clients you do, here are the simple requests you do. If you find out, you actually need to do something more complicated, do client or search, and that interface allows you to do more.
Okay.
But yeah, I'm in favor of like one last package. The unit tests for this aren't that long, even the online queries, like it's very quick. Like it's not, adding this would not be much of a CI burden.
I think it's, if there's that ongoing tap discussion, it sounds like that needs to be resolved first.
Yes.
And then.
Because currently we're constructing the queries by strings. That's.
Yeah, I just wanted to bring it up because we haven't brought it up for a while.
Yeah. So SunPy image is our image processing toolbox. So we did a release of 6.0 was a major release where we had features request Gilly space. I forget Chris Gilly.
Yeah.
Added a couple of filters, and then we got Frederick added wow. So now you can pass in a map, and then it goes through wow, and then it outputs a map. We just import his library. We just handle the input output from his library and wrap it up on the map. There's a few bugs. The major thing is we're trying to, for the GSOC, we did a new co-alignment API. So right now it just supports maps, but eventually we're open to ND cubes. There's a couple of bugs, and Albert, if he's ever bored, should maybe have a look, have a play, see what he can do. So I'm hoping to get that. I'm trying to get this working for Iris and AA. Like I want to see if I can just get them aligned. Right now, it aligns it the other way. So
it aligns it the other way.
Yeah, it's like okay, the shift is like applied the other direction. I'm like, okay, I need to work out what. Yeah.
It just tends to chaos.
Yeah.
Question is the documentation for that is pretty much the examples, or is
that's SunPy image is like I think a library that doesn't have formal documentation. It's just here's how to use it.
Here's a bag of tricks.
Here's a bag of tricks. Here's all the examples.
But do the people, when they propose a change, also are adding like an example or not?
When it comes to tweaks, typically it's like, oh, you want to tweak something like that's a unit test. If someone wants to add a feature,
we are asking them.
I asked them to.
Okay, so every time we add a new algorithm, it gets an example.
Yeah.
Awesome. I mean, I think it's the best way to show off what it's because it is.
Yeah, sure.
It's a grab bag of.
Yeah, so
it's a grab bag of image manipulation. It's perfect.
Yeah, completely pointless to add a function in there, something that does something without an example. So it's like a complete right strategy because how would anyone ever know it's there? They're not going to browse through the API and be like, oh, that's interesting.
Sun can know images.
Finally.
Yeah, this is really nice.
Every feature we add for SunPy image gets an example because.
That looks fucking awesome.
Yeah,
wow.
So that's the wild stuff that Eric.
Whoa.
There's like different ways you can combine the images. Like the underlying code is not really complicated. I don't know what his code does, but like he wrote this example. It's like, oh, beautiful.
Is it like SK image?
Yeah.
This looks exactly like the stuff that SK images does.
No,
This is
So if someone wants to actually try out like alpha level co-alignment stuff for SunPy maps, reviews and problems people find, the better. DRMS is obviously how we deal with JSON queries underneath. This is pretty much stable until they change their API, which they're going to this year, maybe. Obviously, they were delayed through the water leak, the water disaster of Thanksgiving 2024. Oh no, like I don't know if people have seen the video.
Oh yeah, no,
All the video.
it's a disaster. Yeah,
Uh,
just laughed about it.
Yeah.
So they're currently rewriting their entire front end. They're moving to Django, I think. Actually, maybe Flask. I forget either one. So they're rewriting things that require an actual user login instead of like a registration system, as it is now. We'll see what happens, and then changes will have to be made in DRMS. Further changes will have to be made in SunPy as well. But I don't think there's a lot around there. It's going to be a hard break. I don't think there's a way of. We'll see if there's a way of backwards compatibility, but I'll worry about that later. RadioSpectra is an attempt at analyzing RadioSpectra. Shane has been the one leading it for the lots of releases. Like he rewrote the Spectra, he rewrote the RadioSpectra class, turned it into a factory. There are obviously questions about like what data containers we should use. These don't have WCS, so we're looking at cube, X-array, that kind of thing.
Actually, we should put that on the roadmap as well.
Yeah.
Yeah.
Some of these are like roadmap issues as well. Like
Yeah.
attempts at.
What's going on the roadmap?
RadioSpectra.
Just all of it.
Oh,
Yeah.
just put RadioSpectra, nothing else.
I'll wrap up because I guess people want to give lightning talks.
Yeah.
We'll skip that. In relationship to, so we spun up last 2 years, right? So David gave us SunPy, so we spun up SunKit Magix, which contains his code and eventually, hopefully, other types of extrapolation codes. That basically has been relatively stable. I broke everything as I do. I basically had to do a whole bunch of tweaks to the code, deprecation warnings. As part of that, we also took over Steam Tracer, which is now a Rust parallel steam tracing library.
Since we took it over, we added parallelism and did a bit of performance work, and now it is faster than the old Fortran version.
Just think how fast the old Fortran version could have been though if you'd done the optimization work in it.
That's great.
Yes, but critically, I don't have to use Meson to build it. So
Adding more, adding
Yeah, Rust is fantastic for having no dependencies to build from. Yeah.
Adding more approaches for doing field extrapolations is something that that's a roadmap.
Is that a roadmap? Is that not funded now?
Oh, for sorry, I thought you were talking about stream tracing.
No. What do you put on the roadmap?
The person who wrote the code to do the nonlinear force-free extrapolations that's used in that package from NJIT that shall not be named, he released a Python version of that now. So there's actually a Python package that can do nonlinear force-free extrapolations. So we might want to see if that would fit in / work with something Magix.
I think the biggest issue, right, is that SunKit Magix it's built to do a particular kind of field extrapolation, like a global PFSS model, and those nonlinear force-free or like the Green's function methods are built for like doing localized, like Cartesian box like field extrapolations, and of course not you would want the kind of the way in which you do those to like follow the same framework. But right now, like I think once we have sort of a more generalized approach to how we handle field extrapolations in SunKit Magix, like adding whether it's nonlinear force-free or whatever should be straightforward. But right now we don't have that.
I do think that if somebody has a different extrapolation method that they want to add, that we want them to add, we should just do it without the standardization. We can work on the standardization afterwards.
Yeah.
Yes, it's a good goal. Like hopefully because it happens as part of the Aristotle grant.
I completely agree. Yes.
But I don't think we should not just because the API is different. Like it's still be used.
Oh, that's
those
the C, right? That's yes.
I think
C library. Yeah.
Yeah, we should
probably This is a good discussion, but just for people doing.
I'm not going to talk about Sun Expert because I don't know I don't follow repos that I don't have right access to, so unless Shane wants to say anything, but I think we've already talked about.
Yeah.
Yeah, actually, I think we should do that. There's obviously there's like Solomar, which is a way of
making pretty.
Yeah, I thought it was pretty plot on the reader group, but there is not.
Yeah.
There you go.
So this is, I think, it's pretty much stable now. It's bug fix releases, maintenance releases, but it's a fairly stable, mature package. I have no idea what happened to this one. I don't know if it's still being worked on. Anyone know?
Yeah, it is.
Okay, beautiful.
Yeah.
That's correct there, Steve.
I know we also have a Python wrapper around a Fourier correlation tracking routine, which I need to fix the wheels for because.
Desperately need some love.
Oh my god, it's so complicated.
Yeah. Cool.
Okay.
Yeah, I'm gonna stop.
Great. Thank you so much. I guess, long story short, there's a lot of affiliated packages and they all need a bit of love. Good?
Yeah, can you hear me? Hello?
Yeah, we can see, we can hear you.
I will share my screen, okay?
Yeah, sounds good.
Okay. Hello, everybody. I am Carla Lopez. I will explain about my work that I did during my visit in Nagoya University. And
Carla, I think maybe we're seeing the wrong mode in your presentation. I don't know, just in case it's.
Okay, we try it again. Okay. Sorry.
Eso no nos tomamos para no estar. Like, look, you know that first.
Okay. Now?
Yeah,
Can you see? It's a full. Okay,
It's
good. I will talk about my work that I did during my visit at ICE Institute in Nagoya University. The title of this work is a precondition of an X1 class flare observed on 28 October 2021. This work was developed under the guidance of Professor Kanja Kusano. In this part, mainly I work with SunPy package. For this, I have a show multi-wavelength observation of the active region, for example, here, where the solar flare occurred. And this is the solar flare, and this solar flare was associated with other solar phenomena, such as filament eruption, and that is indicated with the blue and black arrow, and the coronal mass ejection. The main objective of my work is try to understand the precondition of the solar flare. For that was necessary to use a space weather HMI active region patches, sharp data. The sharp data series provides several parameters that concisely characterize the magnetic field distribution. Here in this part we have sharp data. From panel A to D, show sharp data in cylindrical equal area coordinate. And the panel A, we have a continued data. This is a magneto-radial component, VR component. This is a bitmap, and this ambiguation. The cylindrical equal area coordinate is a map projected or remap from CCD to heliographic coordinate. In this part, we have an example observation in CCD coordinate, and this is a cylindrical equal area coordinate. The cylindrical equal area, this means that the pixel size in all of that images is the same. That is, the pixel are equals in physical unit. And the unit of this coordinate is in degree. As I mentioned in the beginning, the main objective of my work is to understand the preconditions of the flare. So for that was important and necessary to find what is the main polarity inversion line position. For that we use a VR component, the magnetic radial component, and also the bitmap. And the bitmap can help us to find what is the strong pixel of the magnetic field. it combine both observation data sharp, we can obtain this figure as a result. In this case, we can have some contours. That contours indicate the difference level. For example, the magenta levels is indicate the VZ component that is equal to 0, and that this indicate the PIL, the polarity inversion line, which separate the positive and negative polarity. In this case, the main region, the main position where the PIL is located is highlighted or point out with the white arrow here in this part. And additionally, for this work was important to find where does a trigger reconnection occur during the X-class flare. For that, we estimate the magnetic twist number. This is a magnetic twist number map. And this magnetic twist number was obtained using this equation that is a linear integration of the alpha parameters that is basically associated with a magnetic field strength. In this map, we have blue and red patches that indicate that the sense of the magnetic field. And this is useful because with this magnetic twist number, you can have an idea how much twisted is the magnetic field lines along the active region where the solar flare occurs. Moreover, in this part, we can observe some contours levels, the blue contours. And the blue contours represent the high non-potential magnetic field. And the high non-potential magnetic field was calculated using this equation. And this equation is related to the magnetic field, the component of the magnetic field in X and Y, and the potential magnetic field in X and Y. The magnetic field in X and Y is the current magnetic field, and the potential magnetic field is the calculated using the model nonlinear for free extrapolation. So in that case, we have the non-potential magnetic field is the excess of magnetic field, and these regions can to provide information where is the region with high free energy, what is the position where probably the solar flare could occur. That is all for my analysis. Thank you.
Great, thank you so much, Carla, for a very interesting talk. Does anybody have any questions or comments?
How did you do the nonlinear force-free modeling? Is that in, was that, yeah, I guess that's that. First my question. Yeah.
Did you hear that again?
Yeah, with respect of the nonlinear free modeling, I use the data, the cube data that provide IC Institute. They provide me the potential field, and with the potential field, we estimated a non-potential magnetic field.
Okay. And I think you had it looked like in your previous slide you had a package that was like load nonlinear force-free field. Yeah, this one here, is this a package developed by the institute that you're working at, or is this available online?
Yeah, this is a package for read the NC file. In this NC file, you have all the information, the magnetic field, all the components of the magnetic field and the potential field that is developed for the institute.
Oh, great! Yeah, that sounds really good. Would you mind if it's open and there's a link to it? Would you mind sending it in the chat, that package?
Yeah, of course. I will share the information of that package.
Great, thank you so much. Anybody else have any other questions?
Are you using SunPy to load the sharps images that it looks like maybe it was on the well, I guess the bitmap mask is from this, I guess this is the slide I was thinking of.
Mm-hmm. Yeah, there is a sharp. Basically, I work with a bitmap in this case just to make a limit the regions where I'm interested to find the PIL.
Okay.
Great. Thank you so much, Carla.
Thank you.
Yeah. Okay, up next we have Danny Ryan.
Oh, that's me.
Yeah. Okay. We're talking about NDQ. So back talking about.
It is good to know the long-standing tradition of hastily writing a presentation while the conference is happening has not changed in the decades since I think this might be a record though.
I had no slides when lunch started, and now I have some slides. So
lost in the train crash.
It's like, do as I say, not as I do.
That's,
Anyway,
that's
yeah.
Yeah, that is
Yeah, yeah, that is the way.
thing along those lines. Yeah.
Yeah.
I would not recommend this as a normal thing, but here we go. I can't remember how to.
Press this slideshow button.
Yeah. Okay. All right. So we've already actually spoken the last couple of days quite a bit about NDQ. Not so much to publicize it, but we're looking to use this more and more beyond just the NDQ package in SunPy, and talking about how we support other types of data or other data types. And so there's been a lot of discussion about this. So I thought, but like today there are a few newer people, if not outright new people, who might not know what this is. So I'm going to show a few slides that just sort of summarize what like NDQ is and explains it, so that maybe people aren't quite as lost when we talk about this. And then the last couple of slides, I'll talk about a few things that are new and some things that we hope to be coming in the future. And maybe I can open up to a couple minutes, just sort of summary discussion of what we've been talking about the last couple of days. Actually, how long do I have?
Well, lightning speed.
Lightning speed. Right, very good.
Yeah.
So very quickly, NDQ is a package. It has 4 main classes, 3 data classes and 1 metadata class. The main one I'm going to focus on as part of this talk, just for brevity, is NDQ. This is sort of the workhorse of the package. Confusingly, NDQ is capitalized. That's the class. NDQ not capitalized as the package. In hindsight, maybe I should have thought something better, but there we go. We're stuck with it now. So just to describe very briefly what an NDQ object is, it's based on AstroPy ND data, for those who know what that is. If those of you who don't, that's fine. Basically, it's a data container that looks like this, basically. So you can have data, like these blue boxes here are array attributes. So we've got data. Optionally, we can also have uncertainty, and optionally also a data mask. And then we also have coordinate information, metadata, and unit information, and as well as that NDQ provides various sort of visualization, inspection, and even now like analysis methods, to help with your workflow and actually not just viewing data or storing it, but taking the next step and helping us actually analyze it. The critical thing with an NDQ, the 2 things you basically have to have, all this other stuff is sort of optional or given to you without you doing anything, is a data array and a WCS object that describes your coordinates. So just to give you a sense of sort of the power of NDQ compared to something like map, which is powerful in other ways and has done a great job over the years. So you can imagine if we have like sort of a 4-dimensional cube, we can take sort of a slice of, like a 2D slice of that cube, and it looks like an image like this. So say, this is a particularly lovely sort of butterfly-like sunspot. If we then take sort of a pixel in the celestial slice, that has another dimension, right? So that's spectral. So for this one spatial pixel, we can then view through an NDQ from another dimension, and we get this spectrogram. So we have like time and wavelength. So again, we got space, wavelength, and time, those 4 dimensions. So for this one pixel, we also have like basically another, non-celestial image. And then we can take slices through this and end up getting 1-dimensional plots. So, we can really capture all of these sort of data types, like, so again, celestial, space, spectral, time, even Stokes, potentially others as well. So again, this just gives us one object to represent all these different complex types of data. I'll just quickly run through some of the operations that NDQ can perform. The first sort of really important one, I think, that came along was slicing. So this is using array indices. You can slice an NDQ in exactly the same way that you can slice an array. So you take your NDQ, after you perform this operation, it takes that slicing information and it goes through all the different attributes that are affected by that and change them accordingly. So it slices your data. If your mask or uncertainty there, it slices those as well, and also changes your coordinate information. And as of quite recently, actually, it can change the meta if required, but we'll come back to that. So all of these operations, changing all of these different attributes, used to have to be done manually. Now with just this really simple line of code, you can sort of keep all this consistent and self-consistent very easily. Related to that is cropping. We use 2 different sort of terminology, slicing for array indices, cropping if we want to do it by world coordinates. And this is a little bit different to say things like submap that you might be aware of. Basically, the way that crop works is you describe any number of points within the cube in terms of real world coordinates. So in practice, if we have, say, a space-based image cube, we can give it a series of tuples where we have a time object and a sky coord object, and they in turn represent these single points. You can imagine these blue points here in this. This is an image. Say we're not seeing any of the temporal dimension here, obviously. But it figures out where these points lie within the cube, and then it draws the smallest possible bounding box in array index space, and then crops in that way. So again, a bit different, but quite powerful in n dimensions. We also, this is something actually that is, I think, new since the Dublin meeting that we had a few years ago. And that's arithmetic operations. Will did some work on this as well as a master's student this year, but I'll come back and explain about what's new there. So this is more moving into not just handling and storing and visualizing data, but actually doing a data analysis. So you can directly subtract or even add a scalar or an array or an astropy quantity from a cube. So you can imagine a science use case might be if you have a constant background, you just want to subtract that from your cube. You don't have to go through and figure out what this means for all the different attributes properly. You just use this really, really simple sort of arithmetic operating API that we're all kind of used to using in other contexts. Again, maybe we want to add Gaussian noise to a cube. So again, here we're adding a scalar. Here we can add an array. Gaussian noise of the same shape as the cube. We can scale a cube by some sort of pixel-wise response function. So we can divide or even multiply our cube by, again, a scalar, an array, a quantity. And then just why not? We can cube cubes. Thanks to Will, actually. I think you did some work on this a while back.
I like to think that it's a specific implementation of just cubic.
Oh, really well, yeah. You would like to think.
If not equal 3, raise error not.
Yes, this is not ND square. Sorry. Right?
Does it create an ND cube class?
No, that would be madness. You don't subclass ND cube. Just use ND cube. All right. We had this discussion yesterday. That's right.
Own thing.
Exactly. Yeah. All right. So you can imagine. Obviously, these are just a few examples. This is much more powerful for sort of doing real, like, proper scientific analysis than maybe a few years ago. Other things, rebin, this just shows we have this really simple API. It can be more complicated if you want it to be, but it doesn't have to be. So just using this exact line of code that I did sort of during lunch, I took the AI sample image and I rebinned it so that each macro pixel is now 16 by 16. And you can see, bang, done, it works. So you can improve your signal for noise, you degrade your resolution for, for other benefits and so on.
Unfortunately, your WCS will be off by half a macropixel. But
there is a bug that we've discovered this week in that, but that will be fixed. It's really a bug if it doesn't crash and gives you a nice answer. Yeah, so reproject or reproject 2 more specifically, I think we sort of talked, or Albert sort of mentioned this. You can do this on map, but you can now also do this on cube. So again, I just really quickly sort of hacked away some of the SunPy gallery and instead of using map, used cube. And you can see we're now reprojecting this image to what it would look like from Mars. I didn't have time to make it pretty, but you see that it works. So very quickly, what's new in the last, I don't know, anything between the last few months to the last couple of years. This is very much not an exhaustive list, but I threw it together in the last minute. So the first thing would be ND meta that we mentioned. We've talked about that. This is a new class, a metadata class that enables us to describe access-aware sliceable metadata. So you can imagine, again, we talked about this yesterday. If we have time-varying exposure time, we can put this into a metadata object, say it corresponds to time axis, and then when we slice the cube, the exposure time array or quantity gets sliced automatically. Again, as users, we don't have to worry about all this housekeeping. This is done for us. We also have ND cube squeeze, which was, I think, not necessarily groundbreaking, but certainly really like just handy and just useful. So if you end up with lots of length one axes in your cube, instead of having to figure out and slicing stuff, just like with arrays, you can use dot squeeze, and that can remove those redundant axes for you. Also, something that is really hot off the presses, the next two things,
is extending arithmetic operations. And this is something that Junyang, who was here on Wednesday, this is something that she's been working on as part of her master's project here. So one of the downsides, or one of the, not limitations, one of the incompletenesses of arithmetic operations is that we're only sort of combining cubes with scalars, arrays, or quantities. So this means we can't do operations that have uncertainty associated with them, right? We can't take two measurements with uncertainty, do an operation, and have that uncertainty be propagated. Nor can we do an operation that involves different data masks. And so what we've done is we have enabled you to add or multiply an ND cube to an SunPy ND data object. The reason we don't do two cubes together is because it's quite ambiguous as to what adding two images is. So if I have an image of the Earth and an image of the Sun, like
specifically, it's an ND data object without a WCS, right?
So that's what the reason we use ND data is because you do not have to have a WCS for an ND data object, and this will only work if your ND data does not have a WCS. It was coordinate aware. We don't really philosophically, let alone anything else, know quite how to deal with that. We could try reprojecting stuff, but then again, you can imagine the speed itself. Right, that might be a bit too much, at least at this point.
They need to be consistent axis. Like,
yeah, so
there will be some axis that might be propagated, but it will be the.
So they have to if you extract the data arrays, if those add together, then this works, right? So they have to be exactly the same shape as long as they're like broadcast.
They have to be broadcastable in the same way.
But the ND data doesn't have uncertainty associated with it.
Yes, it can.
Oh, it can do.
Yeah.
Okay.
Yeah, so there is a ND data dot uncertainty.
Is there? All right, okay. Well, that is.
Yeah, and a dot mask, right?
It's it's funny because you say that I mean, it's funny because I think it's cool, but if you've got like say two maps and you want to make a difference on them, then you'd have to convert one, extract the ND data from one, and it's kind of like, well, you can't just subtract two.
So this is something actually Stuart and I talked about a long time ago and haven't spoken about since, but a possible solution to that is to have like a method like drop chords or something, and it would return you an ND data.
It's quite easy to It's quite easy to do that. You just do ND data my map, comma WCS equals none.
Yeah.
Like it's not but it's not the worst thing ever.
Yeah.
I think it's a cool starting point, but I was thinking like any actual use of this, you can manually.
This is required for it to be really user friendly, but we had to get this done first.
Yes.
It's exceptionally difficult to determine whether two WCS are identical.
Yeah, I mean, I think in the past I've thought about it. I never wanted to actually do it, but I thought about like it is close, like like a two WCSs are close enough that you could, but
or you just
I think that the only real way to do that would be to do like pixel to pixel.
Yeah, because this was the thought. If you've got like a sequence of AI images, then they all have a slightly different WCS, but in reality, that's so stupid to have to think about reprojecting 171 onto 193 from the same group of observations. And so this idea that these are close enough, like a context manager or something like that says, assume
same observer.
Yeah.
Have I opened that issue yet? Shit.
So something like dot drop chords, so that could be an easy way for users to do it. Otherwise,
because then this stuff would work in that same. This would work in that same context manager if you assume same observer, and then you can subtract two ND cubes.
It's not just observer,
right? Assume same WCS.
No, you've got,
not necessarily observer.
Or whatever.
Assume same WCS then instead of observer, and then you could then subtract a cube from another cube, and it just knows it can automatically just drop the WCS on one to make it ND data, and then that way you have it like more automagical.
Yeah, that's an alternative solution, which has.
But it still relies on this. It's not alternative. It still relies on the piece.
Oh yeah, of course, yeah. But and that has advantages and disadvantages in how like magic and obscure but easy it might be. So again, that's I'd put that on the table. That's certainly like something that could be developed on top of this, a wider group discussion, I would say. So yeah, in the interest of moving quickly onwards, we also thanks to Junyan, who came out the same project, as we now have a fill mask method. So if you want to replace your mask values with a specific value, both in your data and in your uncertainty, you can now do that really easily. This also has a knock-on effect or implication for the arithmetic stuff. So if you basically want to not include masked pixels in an addition, you can first use filled mask to set them all to 0, and effectively then you just haven't added masked pixels together. But there are other applications for that too. Now these two things have not yet been released, but they will be. They're on main, and they'll be released whenever we do another NDCube release. Also, I realized it's actually been a while ago and I forgot, but ellipsis slicing is supported. That's been there for a little while now, but I think it's certainly since Dublin, if I remember right, checking at the changelog anyway. So yeah, so now use fancy ellipses to do your slicing. Okay, and then finally, what's coming? Again, this is very much not an exhaustive list, just a few things. And again, I think Stuart will have something to pipe up on some of these. Firstly, we haven't got this going yet, but we would, any of these really, but we would like to move towards these in the future. So to support irregular coordinate bin sizes and bin edges, this is really important for SunKit specs or for dealing with, radio, X-ray specifically, but again, there are other applications of that too. We want to have a more user-friendly support for accessing coordinates or performing access type or coordinate-specific operations. So I just threw in some, like that API might look something like this, but that's not decided yet. And also, as Stuart mentioned, we now have, I think in main, or no, not quite, nearly in main, an ability to at least write. We can read as well, right? Yeah, read and write NDCubes to ASDIF, and this like reading and writing cubes easily has been a limitation in the past. So
it supports almost every bit of the cube and all the different combinations of things you can do. Whether you created your cube from a fit WCS or a GWCS, no matter what slicing and rebinning operation is done on it,
yes,
the whole thing gets serialized and
sounds like a challenge. So you're very, very confident as every.
You definitely can find the limits to that. I think every operation you could practically do with the NDCube API would be supported. I can't think of one that would end up in a position where you couldn't save it.
This is not only valid for FITS WCSs either, right?
FITS and GWCS are both supported.
Yeah, and this was a main reason why we didn't. It's still why we don't have FITS support for reading and writing is because some of the operations that we do with NDCube, they basically change the WCS type, and NDCube does not only support FITS WCS, it can support GWCS as well. And so sort of harmonizing that into FITS has been a challenge that we haven't really thought through and solved. But ASDIF is, for NDCube specifically, a much better solution.
Well, are you motivated to solve it because ASDIF is clearly superior?
Emotionally, I'm not, but and I don't know who else is, but I do know that I've spoken to other people before, and they're shocked that you can't get it into FITS because there's an emotional connection to FITS in the community.
What onward stuff are you doing that requires you to have to load a FITS and not an ASDIF?
The biggest problem with like the ASDIF functionality, right, as I just described, is you can put everything, all the weird cubes you can put into ASDIF, right? You're never going to be able to do that to FITS, but also you would have to like to be able to read everything out of a FITS file, right? If you want to read your mask, your uncertainty, what other things have we got these days? Like and your WCS and all of your axes aligned metadata and all that stuff. And then extra quads, global coordinates. If you want to read those things out of FITS, we're basically going to have to design an multi-HDU FITS layout and header spec just for NDCube. And we're never going to be able to have a generic way of like taking a SPICE file and reading it straight into an NDCube, or taking an iris file and reading it straight into NDCube and getting all of that stuff, right? There would have to be a layer somewhere, a map-like factory for reading in actual data like that. And sitting down and writing the whole complicated FITS layout for saving your whole rich NDCube is like a lot of work for.
I think it's actually bizarrely much less work just to do all the instruments and readers like custom. Yeah. Because, normally that sounds like that can't be true, but I think in this particular case, it is, especially if we're talking about instruments, they're going to be writing like readers. It doesn't have to be just the few people who work in NDQ to do this for everybody, right? The instrument teams, really should know their stuff.
Yeah, it's not the reading though; it's the writing. Like the reading from FITS, fair enough.
Yeah,
but the writing to FITS, it's like why? This was what
People love it. Because people do people love it for a good reason? I know those children are wrong.
If you wanted to give it to somebody who was using a different programming language, right? It's harder to load as diffs in other programming.
Yeah, fair enough.
People also know and love FITS, right? We'd be grabbing it out of their cold dead hand, right? We have to.
Yeah. I mean, also
but
as if it's useful, but it's also a huge pain in the ass to work with a lot of the time. Like it's complicated, right? And you run into weird edge cases. They're like, why doesn't this work? Like it's very powerful.
Completely incomprehensible, multi-thousand line error message at you.
Yeah, right. Like FITS has been around for a long time. It has problems, but it's been around for a reason, right? And I don't think there's no reason to give up.
So I agree with Laura, despite the fact my position is we're not going to be supporting FITS anytime.
Pull requests
soon.
But I think it'd be really helpful, to have an FAQ page or something that has exactly what Stuart's just said.
Yeah, probably fair.
Because then instead of someone going, NDQ doesn't support FITS, so you can't use it. It's an educational opportunity.
Well, have you considered that?
Do it yourself. It's not that hard. Here you go.
Yeah. I think we need to move on.
Exactly.
Yeah. Right. So I'll just finish off this slide because it's the last one. Regarding what's coming, what's empowered or enabled by NDQ and might change things in SunPy. One of the big things we've been talking about this week is MapCube. Well, I call it MapCube refactor. Basically refactoring maps so that it's an ND cube underneath. And this is a first step towards greater native SunPy support for lots of data types, not just 2D images. And also we discussed a SunPy metadata control vocabulary, which at least from my point of view was motivated by the new ND method stuff, but this is not dependent on that. So again, this could help us develop and code against reliably available metadata and give us just an opportunity for more functionality. So with that, I will wrap up and
I imagine that since you're using SunPy as the base, follows the array API standard from Python, or there's anything that is.
Sorry, what follows the? Ask the question again.
The API standards from Python.
Yeah.
It doesn't, and I don't think it can. But think about
if it follows NumPy, doesn't follow, doesn't.
Hang on, wait. What are you asking? I think maybe you're asking.
The Python array is API standard.
Are you talking about NDQ being an array or NDQ containing arrays?
But works as an array, yes.
It doesn't work as an array.
No.
I don't think it ever can work as an array.
The array inside is all.
The NDQ, any array-like object, NDQ is exceptionally chill about what array-like object you attach as its dot data. So Dask is fully supported, and I'm sure if you took a React array or whatever else, you can attach it as dot data, and that'll be perfectly fine. Okay. An ND cube is not an array. I don't think it's support the array API because it isn't one.
But the internal part of the array.
The dot data can be any.
Dot data can be
exactly.
Yes.
Great, thank you so much, Danny. Lots of as always, ND cube is going to take over the world. We're going to integrate with. Oh, sorry. Did you have a question?
Yeah, just
sorry.
About visibility data. It is possible to use NDQ for visibility data, or we need to transform to FITS5 and actually manipulate with NDQ.
Possibly. Maybe I'd need to know a little bit more about. Actually, let's talk about that after over coffee because that would be really interesting.
And we should chat to Shane because Shane has done the exact same thing for six. Okay. Yeah. But we'll move on. We'll come back to this. Yeah. Okay, Marcus. Whenever you're ready. Sorry for the
you hear me?
Yeah.
Hi, Marcus.
Get rid of this little box, annoying little box that appears. Okay, let's talk about Punch. And I was really interested in some of the NDQ things you just mentioned, like the uncertainty propagation. That would be very helpful because we do a lot of that manually right now. But just to back up, in case you're not aware, Punch is a small explorer mission for NASA. We have 4 satellites that were launched on March 11th, I think. And we combine the images into a single virtual observatory. So we have this huge field of view because we have these 4 satellites. And to give you context, this movie here on the right is one of our first mosaics. So we threw this together for the AAS meeting in Anchorage last week. There are a lot of artifacts that are still in it. You can see the moon moving across now. You can see lots of edges of images that we want to go away as we add vignetting, correction, and lots of other more careful calibration. But in just a second, I think, you'll see, hopefully it plays over the internet well, an eruption. And if you really like fine tune everything and adjust the color map, you can see it go all the way out to the edge of the field of view, which is wacky. It goes all the way to Earth in the way that we observe it. So we've completed let's play it again while I finish. We've completed the commissioning. We're in phase E now. Our initial data products for level 0, level 1, and then we have this quick punch product for NOAA space weather are going to the SDAC and VSO and can be queried with FIDO. These mosaics will be coming soon. All of our code is public. This QR code just takes you to the press release about this video if you want to read more about it. The main thing that I want to get out of presenting this here is that we believe in open science and we think we could do more by working with you all. So just a little more context, we have several packages as part of our GitHub organization. We have Punchbowl, which is the main calibration code, which is automation that we separated out so that way the average user doesn't have to worry about that. We have some special packages that do very specific things like regularize PSF. You can transform your point spread function into any other point spread function you want to use. So in our case, we can fix the edges of the mosaics, edges of the images so that the mosaics are all uniform. So PolPy for converting between polarization systems. Thuban is not documented at all yet, but you can align your images if you have a star field in them, so that way you get really precise pointing. And then we have SimPunch that makes synthetic punch images, not as useful anymore. And then remove star field that is actually owned by Sam Van Kooten. It's not in this organization, but we use it because he's part of the Punch SOC that models and subtracts stars from images. We heavily use NDCube. All of our data handling is based on NDCube. It's not always using the most recent things. Like we don't use NDMeta because we started a long time ago and didn't have NDMeta around then. And we don't always do things maybe the best, but we'd like to improve that. SunPy and AstroPy are indispensable for our coordinate conversions. Reproject has been a lifesaver for our mosaicing. I don't know, we would have spent forever spinning around if we had to re-implement all the reproject stuff. So we're definitely very appreciative, and we try not to reinvent the wheel. We try to use what exists. To that effect, though, we think that maybe we can contribute back more. We haven't had much communication over the couple of years that we've been developing. But we have some improvements to reproject. Sam Van Kooten is a maintainer, so he's contributed some of those. But even recently, we've had some other little tricks that he's come up with that speed up our reprojections, and those should be fed back. I think he'll take care of that. But we have some custom NDCube serialization. I don't know that you really want to use it. It's very specific to Punch. As you were just talking about, you have to have an assumption about where you put your HDUs and how they're structured and all that stuff. But maybe it's an idea of how to serialize the fits and how to come back from fits into an NDCube that would help someone at some point. We've done some additional coordinate conversions. We had to solve the problem of consistent conversion to equatorial and helio coordinates, which was surprisingly not as documented in like well implemented as we expected. Maybe people don't do that as much as we thought, but we have to do it because we have to go back and forth between Helio, where the Helio scientists are using it, and Equatorial to remove stars and all kinds of other calibration steps.
So have you done that? Have you done that in terms of going from like HPC into presumably in 2D? Because that was something Albert was talking about adding to the SunPy coordinate stack earlier. So have you got an implementation of that?
Yeah, we have an implementation. You should take a look. I can point you to the exact spot because we implemented it as just extra conversions in AstroPy. So we just added to the AstroPy grid, the AstroPy graph of coordinate conversions and.
Oh, well. So that sounds like something that we would want to have upstream in SunPy core.
Yeah, we figured somebody else would want to do this too because
everyone does this for a long time, but it's just one of those things that we haven't got around to. So if
yeah,
we want it.
And we spent a long time spinning around, like thinking we had it right, and then discovering we had like a sign error, like a minus sign instead of a plus sign, and it was painful. So hopefully we can save some people some effort there. And then there are lots of techniques that are in the actual packages, like the PSF regularization. We do this polarization conversions, modeling the F corona. I don't know. It seems like a standard thing a lot of chronographs do. So I don't know how we should contribute that back other than just a part of our package. So the main thing that I want to leave on is we've spent a lot of time working using the SunPy tools and the AstroPy tools. But we want to make sure that it's both directions, that we can give you the things that we think we've developed or improve our code to use the more modern parts of IndyCube, for example. I put a little caveat here that we don't have unlimited funding and time. So there's a prioritization scheme of what's the best way for us to actually do this? Should we affiliate packages? Should we just contribute directly to SunPy core? And it'll probably be on a case-by-case basis, but and we can't answer it all right here, but this is a start to this discussion, I assume. So
great.
That's all I have.
Awesome. Thank you so much. Super cool to see Punch data and that it's so, it's working so well building on the SunPy ecosystem. Also nice to see, I think, when you came first into the SunPy coordination meeting in 2022, and then here we are with some data. So that's
yeah, it was. We were very, very new then. I mean, didn't have any clue what we were doing, and now we have a better idea, but we still maybe don't have a full clue what we're doing.
Yeah, no, it's so good. One thing I guess the first thing that came to mind is that a lot of the stuff you've developed for all these packages, I'm sure would be completely things like Proba 3, right? That the data is now becoming online soon. I can imagine doing the exact same thing that your tools are doing that could be applied to that data, and also things like Metis, right, and Solar Orbiter, right? So I guess in one way, just thinking out loud of like, what way could you contribute back to SunPy? Maybe if these were affiliated packages, then we could point to those instrument teams, or even get them to talk to you about how you found working within the SunPy ecosystem, and that they don't reinvent the wheel, but then maybe we use your tools, and maybe the SunPy project is a way to have that communication between instrument teams.
I did have this idea, like SunPy is very good for like on-disk maps and all those kind of things, but Punch is obviously more of a coronagraph and wide field imager. But there are lots of chronographs, so the people repeat their F corona modeling and all these other techniques, and it might be helpful to have like a CoronaPy or something that is
or like scoping out even what's needed. Yeah, definitely. Maybe we could have a dedicated call on the SunPy community call about chronographs sometime soon, and maybe just discuss some of that idea, Marcus. That would be really good.
Yeah, that'd be awesome. I don't know if I think I often have a meeting at the same time as the SunPy community meeting, but maybe I can move it for this.
Yeah, or we could just try to do a dedicated meeting for that or something like that.
Yeah, that'd be awesome.
So on that theme, Marcus, I know you have met with some SunPy people online over the last while, but I know we've missed each other. And you're right that there has been like a lot of relevant new stuff in NDCube that I've always imagined would interest you. So perhaps it would be good, again, either a call like that or a separate call where maybe we could go through a tour of those in more detail to find out which of these new features can be useful for you directly and just give you a start in how to use them.
Yeah, that'd be awesome.
Okay, great. Yeah, let's figure that out somehow.
I'll send you all some emails or get on the chat or something after this, and that way we don't drop this. So I'll take the action to make sure that this continues.
That'd be brilliant.
Awesome, thank you. Does anybody else have any questions or comments?
Yeah, I'll just say that I am both interested and troubled by coordinate conversions. So I would definitely to see what you've done on the punch side and make sure you guys are doing it the best possible way.
Yeah, that would be helpful too, because we are likely doing something, I don't know, not likely, but it's possible that we're doing something wrong, and we'd like to know that if we
Well, I doubt that. I imagine for the specific punch situation, you might be doing it so it works, but whether you tweak it a little, something it breaks, or it has inconsistency in a round trip you haven't considered, or something like that. We just need to make sure that it's consistent with what we've been building here on SunPy.
Yeah, that'd be awesome.
Albert, I just threw the respective bit of code in Punchbowl into the chat if you want to have a look.
Oh, okay, thanks.
Also, I feel like just so much kudos for Punchbowl. It's so good.
Yeah, it's so nice. I've just cracked it to go and find that, and I'm like, oh, look at all the things you're using, all the things, yay!
Yeah, that's awesome. Thank you so much. If we have no other questions, we'll move on to our last lightning talk. So Mika, I think you're online.
Hello.
Hello.
Thank you for inviting me to give a talk real quick. Share my screen. All right, is everyone able to see this?
Yep. Looks great.
So yes, I was going to give a kind of quick summary of the IcePack, the IcePython analysis code. I know I've presented this a few times over the years. I guess the short answer summary is, we still exist. Development continues. It's been slow. Thank you very much for your kind encouragement and gentle prodding over the years, particularly Will and Daniel. IcePack is kind of the all-in-one or most-in-one Python package for downloading, fitting, and analyzing ice data from Hinode Ice Stream EUV rastering spectrometer data in Python. So we've got various tools, some GUI tools, some command line tools, and of course just a Python package. So you can search and download ice observations either via Fido or a nice little GUI here. I've got to pick the right corner. You can explore the data contents. Last year, we added a GUI for kind of opening up a data cube and loading multiple spectral windows, kind of clicking around to see kind of the spectra. You can also load up fit results, so you can actually see how well your fit matches the data itself, as well as the other parameters such as like Doppler velocities and line widths. I'm working on a co-alignment routine based off of the SunKit routines, and plan to push that out like in the next week or two. Just need to finish some unit tests. But of course, the big thing that this code does is spectral fitting. So we've got a routine that is parallelized for you load in a data cube, you choose your template. You can have a custom template if you so wish, and then it does all the fitting pretty quickly and then gives you results. So kind of this is my last slide here, just kind of for the coordination meeting here. Current integration with SunPy. Right now we've got a Fido client that Will very kindly helped us write, or Will wrote it and kindly contributed. All our data windows we load into ice cubes, which is a subclass of NDCube. Then we can also, after you've done all the fits, you can output ice maps, which is a SunPy map with the fit properties. And then, of course, as I mentioned before, the image co-alignment follows the methods of SunKit image. But at the moment, it doesn't actually depend on it because we didn't want to get lost in the refactor. In the future, plan to kind of extend the FIDO client. We've got a lot of metadata in an SQLite data catalog. And right now the FIDO client is just searching the web scraping and searching by timestamp. So we'd like to get that metadata into the FIDO client. Also, we'd like to update the Ice Cube to actually use like the new ND meta and some of the nicer, more recent features of ND Cube, as well as extending and kind of doing more analysis of multiple spectral windows at once. So you can load in a bunch of windows, select all your templates, and do the fitting without having to loop through each individual set of lines you're interested in. And then lastly, kind of, I guess we need to write some code for better plotting of the sit and stare observations, which are effectively, you know, positioned along the slit and time. So it's a mixed time space axes, which I know the SunPy maps don't really like. And that's what I have here.
Great, thank you so much, Rico. Anybody have any questions?
Thanks, Monica. That's great. It's been a little while since I looked at the IcePack code base, but I was wondering if you could just give some thoughts regarding NDCube, what you found has been lacking and what you had to sort of develop yourself that you think kind of should be more general than just ICE. If you had any comments or thoughts on that. And the second question was, one of the things we've discussed here this week is the possibility or maybe the feasibility of a philosophy where we make it far more possible directly on NDCube to do more like coordinate or axis type specific operations. So yeah, if you had any thoughts on what kind of operations you would like to see, what kind of support you'd like to see directly on NDCube that would really support ICE analysis. Yeah, I was just wondering for any thoughts on that.
Yes. So as mentioned here, we subclass NDCube, which is maybe a bit of madness, but what we had with ICE is we have wavelength correction for everything. And when we first wrote this, the ND meta didn't exist. So we had to write, you know, a separate cube for the wavelength. And I think right now that should be able to be ported into ND meta. So we should then be able to support that kind of multidimensional metadata with slicing and everything. So I think the two things that remain in IcePack are, I guess, two things. There's some convenience functions for like creating a flattened array, which I think would be pretty trivial. A flattened 2D image. We've got some functions for dealing with calibrations. So just multiplying through different calibration arrays, which we hope to extend to actually have all of the historical calibrations for ICE available. So that's kind of an instrument specific thing, but I would suspect that would be kind of a general issue for a lot of instruments. You'd want to be able to have control over what calibration you're using in case you're going back to look at old data and an old paper. How does the new calibration compare to the old and stuff like that? And then I guess as far as like access specific operations, just I guess earlier this year, I added a method for extracting data at given points. So you give it like an array of sky chords for your 2D image, and it extracts the spectra at those given points. So this would be such as like if you had the coordinates of a loop, you could then extract the spectra along that loop. And I think that would probably be a kind of generalizable functionality that I think a lot of people would be interested in, but it would be specific to your kind of type of data, whether or not that even makes sense to do. I think those are the main things.
Yeah, something not quite the same, but quite similar to that we actually discussed on, was it Wednesday, about getting a path through a cube that isn't necessarily aligned with the pixel axes. So yeah, like that's an idea. We don't know how to implement it at this stage, but it's certainly an idea that's occurred to us. So if there's some way of doing that in the future and having that on NDCube, I think that'd be great.
Mm.
I have a question about the image co-alignment stuff. Yeah, I mean, this refactor has taken us forever. But I think Nabil mentioned this earlier, like this is very close to being done, and which I've been saying for months, I guess. But the example that we have as part of the refactor is aligning ICE, because I suggested it, is aligning the 195 line with AI 193. So we actually already have an example, like the PR hasn't been merged yet, but we have an example in that PR that does exactly, I think, what you want to do here. But I mean, I think we're fairly close to that being done, and our release cycles for SunKit image are, whatever we want them to be. So I guess this is just is the plan, like right now, have you just copied the relevant bits out of SunKit image that you needed to do the co-alignment?
Yeah, so we looked at that example there, and then the underlying code, which uses the scikit image for the template matching. So we borrowed the code as recommended in the docs for the finding the best fit from that template matched array. So I think the idea would be once SunKit image is updated, we could go back to using the SunKit image parts of that and just call the relevant function. I did write a backup method that uses just SunPy, just in case someone didn't have SunKit image or scikit image installed on their system, since we didn't want to make it a primary dependency just yet.
Yeah, so if we had a released version that included this new co-alignment, then what would the long-term plan just be to depend on SunKit image?
I believe so. We would depend on SunKit image. We'd still have our own co-alignment function that'd be calling it behind the scenes that has kind of some convenience functions. So you can give it a stack of SunPy maps or a mixture of Sun maps and cubes, and then it'll co-align each. And then I guess this is maybe a bigger question, but one thing that we debated and discussed was for ICE data in particular, anytime you do a co-alignment of images, you're kind of implicitly time shifting your data because the ICE maps are not just a static image, but it's a raster. So you've got kind of time smeared through it. So we actually also update our timestamps to match whatever our reference image is, because your co-aligned pointings doesn't make sense for different timestamps.
Okay. I hadn't thought about that.
What does it change? Changing the time.
Sorry, what?
So if you change the time back to the real time, what is the advantage? Because the image is. Yeah, I don't understand why you need to change the time as well. I understand the each pixel is time.
Also,
but rotating back to align it, I don't understand why you need the time as well. You need to keep the difference of the time if you want to see something different. But I don't understand why you need to change the time.
So in case you wanted to do like coordinate transforms between different instruments and like looking at where is this coordinate from SPICE or EUI or something in the ICE field of view, you would have to propagate that coordinate through time based on the observation times. And for ICE, depending on which reference image you use, you get different co-alignments. So you kind of need to have some sort of record of what timestamp your reference image was.
When you do the alignment, you want the aligned image to be in the same coordinate system as the reference image, yeah?
The image coordinate system, yes.
Yes. And time, the coordinate system, time is a part of that coordinate system. So you want to set time to be the same.
Yeah, but the time is something in the future from that reference time. So
yes,
why would you keep that?
That's potentially a problem.
Sure, so you keep the information, but I don't understand why you will rotate the time as well.
Because you want the coordinate system to be the same.
One side of your ice image is at the different time than the left side.
Yeah, I understand that.
But the thing is, like when you make a map, like when you make these ice maps, you already give up all of that information because it doesn't. There's no concept like in a SunPy map. There's no concept of like a raster, unlike like in in Sun raster where it like does the coupling between those two axes. Like the ice map is sort of like, I mean, it's a very useful assumption to make because it lets you operate on things that just look like maps, but you are giving up that, you're basically saying that like the whole map is a single time, but it's like an hour's worth.
It's a workaround for the fact that you can't do the things you can do on a map as easily to an NT cube, right? Like the correct answer is to have it be an NT cube and still be able to do things like draw them easily on, as previously discussed. Right?
And then to keep that coupling between the two dimensions, because then it would know that like the left side is not the same time as the right side, which would be
but you should have 3 world coordinates for your 2 pixel objects.
We do in the ice map subclass now, we do have a convenience array where it gives you the timestamps of each raster position. There's no slicing of that or coordinate transformations and such. But like if you wanted to know what raster position 10 was in real time, like the actual observation time, it is available there, just for reference.
The only other thing that I wanted to bring up, I don't know whether you've seen this or not, but over the last few months, there's been a lot of work done, partly by me, partly by Tom, on massive performance improvements to AstroPy modeling and a parallel fit helper in AstroPy modeling. I wrote an example of using it with ice data, or I think will help me. I just thought you might be interested because I know back when you wrote your fitting code, it wasn't wasn't fast enough and like what you wanted it to be, but there's been a lot of improvements there now.
Yes, I've heard about that, and I'm very interested in taking a closer look because I think ultimately just for historical continuation with the fit results in IDL for ICE, all using MPFit. But we would like to take a look at that and try to use the AstroPy modeling more.
I just put a link to the notebook, the example notebook in the GNC chat if you want to have a look.
Wonderful. Thank you very much.
Great. Thank you so much. This is really good. We are a little bit over schedule, but that's okay because I think it's been good discussion, right? You don't want to cut these things down. It's nice to actually be able to talk about this. Just before we kind of finish up officially, Albert, do you want to talk a little bit about Astolfo?
Yeah, I'll just go really quickly through. It's not like a fancy thing or anything. How do I start? Allow to share screen. Share this screen. Okay. Okay. Can you see my slides?
Yeah.
Yep. Okay. Yeah. I'll just go through this quickly. As most folks are aware, we had NASA roses Astolfo funding for 3 years. Astolfo stands for Open Source Tools, Frameworks, and Libraries. Funding throughout the Science Mission Directorate, various efforts. SunPy had a Astolfo award. So did folks at AstroPy and Matplotlib, SciPy, X-Array. A bunch of people, all usual names, got funded the last time. The opportunity came around again, so we applied again. And so right after our first award was running out, we got awarded a second 3-year stint. So the first award was about $640K total. It was about strengthening the foundations of the SunPy ecosystem. A lot of infrastructure side stuff was the intent. And then the next 3 years is about what we call enhancing consistency and discoverability. As we grow our affiliate packages or we grow our ecosystem, we certainly don't want things to fracture in terms of consistency. Help people to find things. And an important element of the second award, the first award was me, Stuart, and Will primarily funded. The next award, importantly, has folks from SAO and University of Minnesota. SAO is Sam Badman on the SunKit Magic side, and then on Minnesota, it's Chris Cooper for the SunKit Spec side. That's kind of the breakdown on the right there, roughly speaking, about what fractional labor time and the main tasks are enhancing documentation, because we're talking about an ecosystem level documentation, and then working on those specific affiliate packages, and then just keeping things going in terms of the health of the maintenance of the ecosystem. Enhancing documentation stuff, just trying to get the documentation better, and also trying to figure out how to have a better example gallery, especially across the ecosystem. Here's kind of what Sam broke down for the work on SunKit Magics. And yeah, just trying to get a better, I guess, part of the, as cast inside of the Stoffel program is about providing the hooks for other types of extrapolation methods, not necessarily to actually insert and add them, but it's at least to have a good API and interface for future support. For SunKit specs, here's what Chris laid out for his 3-year plan. Just really trying to get it more into shape. Of course, as things become more possible through NDQ, I'm sure this is all subject to change. And then maintenance stuff, nothing really exciting there. So our status is we technically got this award, and I've been sitting on the money in October. One note, it is 8 months past October now. The funding still hasn't got out to the institutions, although I think for at least one of them, the one to Will, might be the furthest along, since they actually acknowledged the start date you asked for, Will, right?
Yep.
So that's a good sign. If they're thinking about the start date, that means that it's getting close to the light at the end of the tunnel. The other 3 are at various stages, I think, earlier in the process. But in actuality, that means sometime later this year, all 4 sub awards will hopefully get set up, and then the respective people can actually be funded for their work. And that's it.
Great. Okay, I think this has been great. I think us in the room need a break. Well, it's the end of the day, so maybe we will kind of wrap up. I think it's been quite a productive meeting. I think what we'll do now is maybe take a group photo, just to say that, to prove that we were actually all here. And maybe this is actually something we could do with people online.
Yeah, could we do it in front of the
let's do it in
screen?
front of the screen. So the people online want to turn on their camera. I'll go find somebody to take a photograph, and then we can all stand up there and make crazy faces.
Excellent.
Yeah. Yes, if you are in the room and you're still on Jitsi, can you log out so that we can, I'll leave mine up. No, wait. Who is? I'll give it over.
There's the whiteboard.
You don't want everyone to leave, because then
Yeah.
their faces will just be giant. Giant Albert and Shane behind you guys.
Yeah.
You're pretty much life size at the moment.
Yeah.
While we're waiting for someone, just to say quickly that Danny has a proposal in for more funding.
Oh, sorry, Dan.
Yes, sorry, but yeah.
Which a few of us helped with. So we will see how that goes. And yeah, I also wanted to say that we're in a really good position here at UCL, in that we have Danny and other people at MSSL who are scientists. We also have myself and David and other software engineers who can accept funding to work on SunPy, and it doesn't have to be a loss of funding. We can do in pieces. So if people see funding opportunities, then I think we're pretty keen to apply for them.
Absolutely. Yeah. So that proposal that David mentioned, we put in a step 1. Step 2 is not yet open, or will be open soon. And we proposed for $500K over 2 years, which would include a Perio and UCL.
There are small awards as well, like 150K for 1 year. We didn't apply for that. But we'll see what the feedback is, and assuming we get through to step 2, and then we'll see what the decision is on that sort of at the end of the year or early next year.
That's great. I never actually really thought about, yeah, UCL is in like the perfect place to kind of be the European, like, yeah. Side of this. For sure. Okay. Oh my God.
And we can involve other institutions.
Yeah, no, of course.
Not
But
to be exclusive.
no, sorry. It's just a good to like have a relationship for sure. Yeah.
Photographer?
Yes, okay.
All right, everybody, come on, mush.
You want to discuss
Yeah.
this?
Right, so you go there. No, she's in a bit. No.
Go on.
Oh, like here. Yeah, like we're in a.
You might need to do.
No, you go between them.
You can position your head right there.
Yeah.
Try not to stand on the cable.
Oh, all one. No, we have. There we go. And second row. There you go.
There you go.
Where's Raphael?
He is.
Sleeping.
That's right. What are you doing?
Don't kneel down.
I wanted to show the result of that nonsense there.
Okay.
Okay, I think that works. Okay, let's try this one. Yeah, instead of on the screen. Okay, SunPy. There. All right.
Thank you. Thank you.
Do I get stickers now?
Yeah. I also finish early. Thanks, David. Thank you so much for hosting us here. It's been brilliant. It's a really great space, and it's also been great to see you.
Yes.
I mean, happy to see all you
Maybe
here.
remind him what the sun is. Yeah. His long period in the darkness.
Thank you so much.
Thanks.
Extreme.
Thank you. Now we have to restore the room back to normal, right?
Yeah. Wait, they're frozen.